Good morning, everyone, and morning. Sorry, it's evening, I guess.
Good evening, sir.
Well, so this is lecture number 8 of mechanics, right? So till now we have completed how many topics? कितनों को याद हो चुका है अभी तक syllabus? I have given already in the assignment also. How many of you have remembered the syllabus? No one. Syllabus should be on your fingertips. Please do that. Assignment, how many of you have completed 50% of the assignment? 50% किसका हो चुका है अभी तक? अरे यार, is there any issue with the assignment? क्या दिक्कत आ रही है?
No, sir.
सब कुछ नोट से ही है ना उसमें?
Yes, sir.
कर लो यार, नोट्स रिवीजन की लिए चीज है. Okay, so till now we have completed we have started with the laws of mechanics, then equation of motion, then we have seen the conservation theorem of energy and momentum. Both of them are repeated, both for particles as well as rigid body we have seen, right? Few more topics we will be covering rigid bodies, right? Then we have seen for the center of mass and laboratory frame of reference. Then we have seen the system of particles, center of mass, elastic and non-elastic collision. Now in elastic collision there is a specific measure of Rutherford scattering. So Rutherford scattering is nothing but a elastic collision, oblique elastic collision that we have studied, right? In which we will be studying Rutherford scattering as well as hard sphere scattering. Two things we have to study. So this is what we are going to do today. But before doing that, let us practice few questions. Okay, then we will move ahead.
सर एक क्वेश्चन बाद में डील कर देते हैं, पहले टॉपिक पढ़ा देते हैं.
क्यों? भाई एक बात समझो, मैं बहुत पहले क्लियर करता हूँ इन चीजों को, ठीक है? UPSC में if you are comfortable with 90% of the syllabus and if you haven't studied 10% of the syllabus, then you can score greater mark unless you have 100% syllabus coverage but कुछ भी ढंग से रिवाइज नहीं है, ठीक है? So numericals are going to us. Have you seen the past 5-year papers? सबको homework दिया था. How many of you have seen that? Last 5-year papers, paper 1. What is the percent of numericals that they have asked? What is the percentage of numerical that they have asked?
सर मैकेनिक्स में तो न्यूमेरिकल्स ही लग रहे हैं सारे.
90 to 95% the questions are based on either numericals or derivations. Derivations are very few there. 90% are numericals. So we have to focus on that. First thing. Second thing, I have always said that it is not a humanities classes, right? That will be a monologue कि teacher आएगा वो भाषण देगा और चला जाएगा. It is something that you have to put your hard effort. ठीक है? Mind it, on the very first orientation class I have told you that either you will do the hard work and get more than 300 plus marks, otherwise it will be very difficult to handle this option. This is a hard work thing. Chalo. A particle of mass m is head on colliding with mass m. Assuming the mass m is moving with velocity v naught and m is at rest. So not head-on colliding, simply colliding. Assuming the mass m assuming the mass m is moving with velocity v naught. अरे या एक मिनट रुको. And m is at rest. ठीक है. If theta dash is the scattering angle, if theta dash is the scattering angle in center of mass frame, A, find velocity of m in L frame. And change in kinetic energy. Change in kinetic energy. Find final velocity. Initial to given here. Find final. One more thing. See, you will be seeing that we are doing numericals in launch session, right? Numerical session, and as well as in your class, lecture class, right? Whatever the thing that we are doing in the lecture class should be on your fingertips. Okay. Even the numerical that I am doing in the class, right? It is one of the numerical that is asked in the UPSC, right? This numerical was asked in the UPSC CSE. So understand this thing. So whatever we are doing in the lecture class, it is relevant to do in the lecture class. That's why we are doing it. Other practice numericals are there, right? So why they are in your notes? Because these needs to be revised again and again. These are the things that should be revised compulsorily. The question that I give in the launch, apart from the PYQ, they are practice question. So at the end, सुन लो सब कुछ reason समझ लो क्या है, right? When you are at the final stage of revisions, last final 5 revisions, you will be revising your notes only, not all the launch sessions. ठीक है? Everything got the meaning. Is it okay? कौन पूछा था ये उस टाइम? कौन था वो व्यक्ति? रामाशीष?
यार मैंने बोला था कि थ्योरेटिकल में थोड़ा ज्यादा दिमाग लगता है, इसलिए पहले उसे पढ़ा दीजिए, उसका न्यूमेरिकल तो थोड़ा इजी रहती है, इससे बाद में भी देर कर लिया जाएगा।
तुम्हें इसका आंसर तुम ही बताओगे, जल्दी बताओ।
तो रिवाइज नहीं हुआ अभी तक।
फिर क्यों रिवाइज कर? देखो सुनो, मैं बता रहा हूँ, इसका जो डिमांड है ना यूपीएससी का, ये थोड़ा सा अलग है, ठीक है। इसको तुम्हें बार बार रिवाइज करना होगा, ये जानते हुए कि तुम्हें आता है। ये लिख लो कहीं पे सब लोग, राइट। दिस इज इम्पोर्टेंट टू
ओके सर।
अंडरस्टैंड, ठीक है। कि तुम जब खोलोगे ना अपनी कॉपीज, तुम्हें लगेगा सब कुछ आता है तुम्हें यार, बट फिर भी तुम्हें उसको रिवाइज करना है, ठीक है। And please do revision alongside, otherwise it will be a huge backlog, trust me. और फिर वो होता है कि क्लास में तो सबको समझ में आता था, अभी नहीं हो पा रहा, ठीक है। सो ये वाली सिचुएशन नहीं आने देना, क्योंकि देखो अभी सब लोग इनिशियल फेज में हो, है ना। इफ यू स्टार्ट वर्किंग नाउ, देन कोई दिक्कत नहीं होगी। So I'm just making it from the lab. Now when we are doing, सुनना अच्छे से, I have told you that always try to make the diagram in mechanics, right? In the assignment session, I have told you that try to make the diagram in the mechanics. Let's say this is M, which is moving with V, and it is at rest. Now, in the last lecture, I have given you one note, right? In the note, I have told you that always mention the frame of reference. Do we have to mention the frame of reference or not here? In which frame? किस frame ऐसा दिख रहा है? A particle of mass m is colliding with mass m, assuming the mass m is moving with velocity v naught, and m is at rest. If theta dash is the scattering angle center of mass frame,
थ्री फ्रेम सर।
कौन सा frame है ये?
थ्री फ्रेम सर।
This is seen in the L frame, no?
एल फ्रेम, ग्राउंड फ्रेम।
This is seen in L frame, but the scattering angle is given in center of mass frame, right? So I have already taught you the triangle wala cheez, yes or no? So what will be V center of mass? What will be my V center of mass? एक काम करो, उसको V नॉट कर लो, ठीक है। So V नॉट तो है ही, this is V नॉट. So what will be my V center of mass? M V naught
अपॉन एम अपॉन m1 m।
M plus M. Very good, very good. चलो. Now, whenever you are asked to convert from L frame to C frame, right? Always try to use the triangle, right? Based on this triangle, UPSC in last 10 to 15 years have asked almost 4 to 5 questions, which can be easily solved using this triangle only, right? What was the triangle? Anyone remember? This is V center of mass. This was what?
v1c।
So here is V naught. So V naught C we have, right? And here it will be having, क्या होगा? V or V naught? Let's say. Solve it. This is my theta. This is my theta dash. Sorry. It will be my V1 na? And it will be my V1C. It is the after the scattering na, where V1 is what? Final velocity of m in left frame. Yes or no? This triangle we have made after the scattering, na? Having theta as scattering angle in left frame, theta as in this. Yes or no?
Yes, sir. Yes, sir.
Chalo. Now, one more thing we know that things will become easier. That V1C is equals to U1C. With respect to center of mass, we know that their velocities are not changing. So, just writing the magnitude, what you can write here? What is U1C? U1C is what? V naught
minus VCOM.
V naught minus VCOM, right? Now with this triangle, use this triangle. What you can write here? Can I write? Use this triangle.
V1 sin theta is equals to V1C sin theta dash.
You can write this thing V1 plus V center of mass plus V1C. Yes or no? From this triangle.
Yes, sir.
Everyone,
Yes, sir.
Yes,
Yes,
sir.
sir.
try to understand the flow, that how you will think in the examination. The very solution of this question is not matter, is how you will approach this question. Now just square them. So I can write V1 square is equals to क्या जाएगा? V center of mass का whole square plus V1C is what? I'm writing it as V naught minus V center of mass का whole square. अरे A square plus B square. How you write A dot B? यही तो होता है वेक्टर का. Into 2 into V center of mass into V naught minus V center of mass. बताओ और क्या आता है? अरे what is A plus B का whole square? How you write it? It is A plus B dot A plus B. पता है ना ये सब चीजें? That is equals to A square plus B square plus 2AB cos theta. Yes or no? Everyone know these basic
Yes,
formulas?
sir. Yes.
What is the angle between them? What is the angle between this V center of mass and V1 dash? Theta or theta dash? Theta or theta dash? जल्दी बताओ. What is the angle?
So theta dash.
So everyone know that. So if this is my vector, this has to be tail by tail. Then it will be theta dash. So cos theta dash. देखो कुछ आ रहा है क्या? Put the values. You can find all the things. We have to find V1 now. You have to find the V1. You can find it easily. What is V center of mass का whole square? So it is mv naught upon m plus m. You can also take. चलो सॉल्व कर लेता हूँ. What will be V naught minus V center of mass? Can write it? It will be mv naught upon m plus m. तुम जो तो एक स्टेप और कर सकते हो माइनस करके. यही हुआ ना. V naught minus mv naught upon m plus m. So it will be m plus m into v naught minus m v naught upon m plus m, right? So it will be left. Now next is 2 into m v naught upon m plus m into capital M v naught m plus m cos theta dash. ठीक है, so what will be v1 बताओ, तो आसानी से देख सकते हो, रूट अंडर करोगे, so what will be coming outside, सब में से v naught by m plus m तो बाहर आ जाएगा, right? And then under root what will left, from the first it will be m square, from the second it will be m square, from the third it will be 2mm cos theta dash. How many of you got this answer? How many of you got this answer? चलो,
सर मुझे 9 के बाद जो स्टेप लिखे वो समझ नहीं आया।
इसके बाद से मैं यहां से
और यहाँ यह
देखो, ये ट्रायंगल दिख रहा है, फ्रॉम दिस ट्रायंगल कैन आई से दैट कि दिस वेक्टर प्लस दिस वेक्टर इज इक्वल टू दिस वेक्टर, ट्रायंगल ऑफ एडिशन लिख सकते हैं,
यस सर।
ठीक है, तो वही लिखा हमने यहाँ पर v1।
नो सर, फर्स्ट स्टेप।
यार ये समझ में आ रहा है, फर्स्ट
यस
है
सर।
v1c बराबर u1c, फ्रॉम ये क्या है, v1c क्या है, फाइनल वेलोसिटी विद रिस्पेक्ट टू द सेंटर ऑफ मास, it is final speed with respect to center of mass, yes or no? So in the last class we have understood this thing, last class में पढ़ा था ना हमने,
यस सर।
that u1 dash equals to v1 dash, यही तो है, u1c equals to v1c, same thing,
यस
that the speed of the each particle remains same before and after collision, वही हमने यूज किया है।
ओके सर।
Now v1c is equals to u1c, and what is u1c? u1c will be u1 minus v center of mass, यही तो होगा, और what is u1 given in the question, it is v naught, so v naught minus v center of mass, clear है? उसके बाद तो हमने इसका होल स्क्वायर कर दिया है, गॉट इट?
यस सर।
चलो गुड, आ जाओ, कमिंग टू द सेकंड पार्ट ऑफ द क्वेश्चन बी, they are asking delta ke. From the delta ke also you can understand that whether it is an elastic collision or not. If delta ke is equals to 0, we can say it as a, क्या बोलेंगे इसको,
इलास्टिक कोलिजन।
इलास्टिक कोलिजन, तो देखो है या नहीं है, तो डेल्टा के is equals to half mv square minus half mv naught square, यही तो होगा, फाइनल माइनस इनिशियल, फाइनल क्या है, इनिशियल क्या है, माइनस करो दो कितना आ रहा है, let me know the thing, and also then find out delta k by ki, this was asked by UPSC, delta k by ki बताओ कितना आ रहा है,
सर इसमें सर बड़े वाले एम की सर फाइनल काइनेटिक एनर्जी जीरो ही मानते हैं ना हमेशा, वेलोसिटी
नहीं,
ग्रेटर है
हाँ अज्यूमिंग
हमेशा ही
दैट,
सर।
हमेशा ही नहीं, but यहाँ पे अज्यूम करते हैं कि हाँ it is so big to do that, m is greater than,
पर अपन सर कल से पढ़ते आ रहे हैं, मतलब ये ऑब्लिक वाले में हमेशा जीरो ही मानना है बिल्कुल।
m is greater than m, it will be mentioned in the question, ठीक है, otherwise नहीं मान लेंगे हम लोग, ठीक है।
सर अपन ने सर ये वाला केस नहीं पढ़ा है ना, जिसमें सर ये ग्रेटर एम की भी कुछ वेलोसिटी हो,
और देखो ग्रेटर एम की वेलोसिटी होगी, देखो दिस विल रिमेन अनचेंज, इसमें तो कोई फर्क नहीं आएगा, ये सुनो, बस
यस सर
डेल्टा
इसमें नहीं है।
के में अंतर आएगा, ठीक है, तो नहीं अभी तक हमने वो नहीं पढ़ा है, रीजन बता रहा हूँ मैं क्यों, व्हाई दिस सो, बिकॉज दीज आर द एग्जांपल ऑफ न्यूट्रॉन स्कैटरिंग, ठीक है, तो अल्टीमेटली क्या होता है कि अ वेरी वेरी स्मॉल पार्टिकल इज टारगेटिंग अ बिग ऑब्जेक्ट. तो 90% ऑफ द केसेस दिस इज द थिंग, दैट्स व्हाई वी स्टडी दिस. तो हम जनरली वही केसेस पढ़ते हैं जिसमें जो चीजें कॉमन होती हैं. ठीक है, जो अनकॉमन चीजें हैं, सिचुएशनल है, वो हम लोग सॉल्व करेंगे अपने न्यूमेरिकल सेशंस में. ठीक है, क्लियर है?
यस सर.
कितना आएगा बताओ? हाफ एम बी स्क्वायर माइनस हाफ एम बी डॉट स्क्वायर. ये निकाल लेना जो भी है. डेल्टा के वाई के आई आ रहा है, जो मेरे पास आंसर है, प्लीज मैच करना अगर आ जाए तो. 2mm 1 माइनस कॉस थीटा डैश अपॉन m plus m का होल स्क्वायर. Let me know if it is coming or not. V और V1 is the same thing है ना? If you want to write, you can write V1 here. Put the values. इतना बड़ा तो है नहीं कुछ टास्क. अरे यही तो बचेगा, क्या ही है इसमें यार, इतना क्या टाइम लगा रहे हो? हाफ एम बाहर ले लो. What is V1 square? What is V1 square? V0 square upon m plus m का स्क्वायर मल्टीप्लाई बाई m स्क्वायर प्लस m स्क्वायर प्लस 2mm cos थीटा डैश माइनस.
सर ये नेगेटिव साइन आएगा सर. मतलब 2mm cos थीटा डैश -1 आ रहा है सर मेरा.
देख लेते हैं आगे. तो हाफ
2mm
हाफ m हाफ m v0 स्क्वायर अपॉन m प्लस m का होल स्क्वायर. दिस आई कैन टेक कॉमन. ठीक है, एंड हेयर क्या आएगा? m स्क्वायर प्लस m स्क्वायर माइनस 2mm cos थीटा डैश माइनस ये हो जाएगा सारा. तो माइनस क्या आ जाएगा? m स्क्वायर प्लस m स्क्वायर, नहीं सारा माइनस आ जाएगा ना फिर तो. माइनस 2mm ये आ रहा है ना?
cos थीटा डैश -1 आ रहा है ना.
देख लेते हैं. हाँ शायद वही आएगा. सो इट विल बी कमिंग आउट टू बी m स्क्वायर m स्क्वायर खत्म हो जाएगा. so 2mm if you take outside, so it will become कितना? mm. so 2 कैंसिल आउट. प्लीज चेक कर लेना एक बार. m स्क्वायर m v0 स्क्वायर m प्लस m का होल स्क्वायर. here it will be cos थीटा डैश -1. यार है?
यस सर.
ठीक है. सो इफ यू डिवाइड इट बाय इनिशियल काइनेटिक एनर्जी क्या आएगा? if you divide it by initial kinetic energy, what is initial kinetic energy? half m v0 square. so what will क्या चला जाएगा? v0 से v0 खत्म, एक m से एक m भी खत्म. it is coming out to be 2mm upon cos थीटा डैश -1. हाँ ये आना भी चाहिए था ऐसा, आना भी चाहिए था ऐसा. Why? Otherwise what will happen in the last जो मैंने लिखा था 1 minus cos थीटा डैश, वो तो पॉसिबल आया था.
यस सर नेगेटिव कम हो जाएगी काइनेटिक एनर्जी.
it should be negative, yes or no? है ना? This is the correct one. So 2 mm. अच्छा देख लेना. See the question that I have given you. Again, it was asked in UPSC and it is again from the DS Mathur, right? So the answers that they have written might be sometimes incorrect. So please cross verify कर लेना. ठीक है? Not just the any book, but check the calculation once again. सब लोग एक बार और कैलकुलेशन चेक कर लिया करो. क्लियर है यहाँ तक? Right? Why it is less than 0? We know that ये तो cos CV है. Cos is always less than 1. -1 will be always less than 0. That means the final kinetic energy is lesser than 0. और तो क्या बोल सकते हो यहाँ पे? और क्या बोल सकते हो? It is what? Theta dependent. And independent of the initial kinetic energy. It is independent of the initial kinetic energy. I will tell you in the numerical sessions, right? You what to write in the conclusion of these topics. Okay. This will again, the same question will again come in the community numerical session. Exact question मैं बोल दूंगा जो तुमसे UPSC ने पूछा है, which is almost similar to this one. Almost similar to this one. Okay. So I want everyone to focus upon this thing. अगर ये independent है initial kinetic energy के, that means what type of neutron you should take? Fast neutron, thermal neutron, all those things. So these aspects we will be doing in the numerical session. Clear? यहाँ तक everyone? Do one last question, then we will start with the other topic. Obtain an expression for the fractional. ये तो कर लोगे यार. ये सेम ही क्वेश्चन है, कर लोगे. बस इसी में न्यूमेरिकल वैल्यू पुट किया. Okay, don't worry, we will put in the numerical session. ठीक है? So let's move on to the our next topic, that is the Rutherford scattering. Anyone, please, we are moving away from the collision. Although scattering is a type of collision, but formally जो है syllabus में collision हमारा वो हो गया है. So please, if you have any doubt, please ask. Otherwise, we will start with the scattering. In scattering, they have specifically mentioned Rutherford scattering, but they also asked the question of hard sphere scattering. That also we have to cater. Now, already I have told you what do you mean by scattering, right? What is scattering? What is scattering? Is it a type of collision or not? Type
Yes,
of
sir.
collision, deflection of particle, all those we have understood. Please try to understand the three major characteristics of the scattering, right? So this is a type of collision in which particles do not change. Now you will be asking, what does it mean? Particles do not change. See, when you go into the subatomic level, right? And if you have different type of atoms, those atoms might change in case of colliding with each other. In case of collision, right? Those things can change. Proton can change to neutron, all those things happen. So we are not asking about, we're not interested in that thing. So let's say if A is colliding with B, if A is colliding with B, after the collision, you will get again A and B as same physical and chemical property. Only the parameters, kinematic and dynamic parameter will be changed. That's why we are able to do it in the mechanics section. Almost all the scattering that we will study, 90% of the scattering belongs to the subatomic particle domain. proton, neutron, or all those things, right? Where particle might change. But in case of scattering, what we are considering that the particle are not changing, right? Same thing, right? Mainly concerned with the, I already told you in the last class, deflection of particle. Mainly concerned with the deflection of the particle. And third thing, that most cases, and if not specifically mentioned in the question, we will treat them as elastic. Most of the cases that we are encountering here will be the elastic. ठीक है? So understand, एक चीज और लिखी लो यहाँ पर. Have you guys heard about delta E equals to mc square formula? सुना है कभी? E equals to mc square.
Yes, sir.
Rest mass energy, binding energy. Then if you have two particles, when they collided, the energy, let's say binding energy is raised into delta mc square, mass defect, all those things. Have you studied these things in your junior classes?
Yes, sir.
थोड़ा बहुत तो बड़ा होगा. So here, what I mean to say that particle do not change. That means like its mass will not change. Its charge will not change, or any other property, which might happen for various reaction in subatomic particle. Okay, so scattering is that type of thing, right? Now I have already told you that in scattering we have to study about two particles mostly. We have to study about two particles. Okay, size doesn't matter. Okay, always remember, size doesn't matter, only the mass matters here. So let's say it is capital M and it is small m, right? It will have some initial velocity, V naught. We will also study about the impact parameter, but as of now, just understand. And slowly it will get deflected. This will be the deflection. Okay. Now what you need to understand here, okay? Most cases it will be, most cases it is generally of very lower mass. When I say lower, it is comparative with the this one. Okay, have high velocity. It is generally massive and generally at rest. Okay, what we call them as? We call them as target, and this is known as, क्या बोलते हैं इसको?
projectile.
Very good. Okay, this is what we have. Do you guys know basic idea about solid angles? Solid angle पढ़ा है कभी? It is mentioned in class 12 NCERT. Let me.
यस सर, 3D में होता है सर. तो 3D फॉर्म में होता है, इसकी वैल्यू 4 पाई होती है गॉस थ्योरम में.
ठीक है, very good. So it is in the 3D form. और कोई? See how we define. We have two types of angle mainly. Plane angles are something which can be defined by two dimensions, right? And here how we define it. Let's say if this is my circular arc, so based on this circular arc we measure any angle, right? So let's say if this is the angle that we have to measure, it is theta. And let's say the radius of the circle is r, it is L. So we measure theta is equals to L by R. ये सबको पता है. This is a two-dimensional angle. Everyone knows that. First thing, we define angle as this when we are moving in the 2D. But when we are doing into 3D, how we define? We define usually solid angle. Solid angle, 3D. So instead of this small angle, it will be making a conical type shape. So let us consider this as sphere. ठीक है, ये एक sphere है. This is a sphere. So when we start moving and making out an angle, it will not sustain any arc. Rather, it will have certain area. Yes or no? समझना अच्छे से. Please try to visualize it. If you will visualize it, if it is a 2D, then it will be an arc. This is my arc. It is a 2D. It is just this arc. But let's say if you are on this sphere, assume karo, you are inside the sphere and you are at the center, and then you just have to measure this angle. So what you will do, you will just make the cone, and out of this cone, this area will come out, right? And this area, sorry, this angle we known as omega. And here omega is defined as BA perpendicular by R square. Why R square? Because both angle and solid angle both are dimensionless quantity. Both are what? Dimensionless quantity. So you need to understand why A perpendicular, because let's say for this small area, for this same omega, we can have various type of areas. What we will take? We take always A perpendicular. Here also, just try to match it with the plane angle. In the plane angle also, it is along the tangent. L is always perpendicular to the R. Yes or no? अरे इस वाले में L क्या होता है हमेशा? Perpendicular to the R. If हमने पढ़ा है ना polar coordinate, it is along the direction of theta and it is along the direction of R. So they are always perpendicular. Same goes here also. Same is the concept here. Everyone getting it or not? यहाँ तक समझ आ रहा है सबको?
Yes, sir.
चलो. Again, it is mentioned in your NCERT. What I want to tell you that how you convert. So conversion of solid angle to plane angle. And this formula you can use directly. No need to. इसके पीछे कुछ बेस करने की जरूरत नहीं है. So let's say if this is अच्छा एक चीज और कर लो, मुझे बताओ what is theta full here? If you take all around the circle, what will be theta full? So you say that
2 pi by R.
R is equal to by R, that is equals to 2 pi. What can be sigma full here? Area ही तो निकालना है. So what is the full area of the sphere? It is
4 pi R square
square
upon R square.
divided by R square. Very good. It will be 4 pi. ठीक है, इतना याद होना चाहिए. Again, is one of the One of its application will be seeing in the electricity and magnetism chapter also, right? Now when it you project, projection समझ में आता है, इसको दबा दो, तो its projection will be something like this, ऐसा कुछ दिखेगा. Remember, it is theta, it is theta. That means total 2 theta is making here, right? Using the concept of integration, you can prove it also, but we are not required to do so. हमें जरूरत ही नहीं तो क्यों करेंगे हम लोग, है ना? If you want, you can just check anywhere. Okay, how to prove that? I know that sigma, sorry, this omega can be written as 2 pi 1 minus cos theta. Using integration, you can prove that, but it is not relevant for our examination, so we'll skip that. This you have to remember, right? And you can use this relation directly. This is so basic. This is a theta equals to L by R, है ना? It is so basic than that. Okay, so you can use directly. Now we are more interested in this by d theta. क्या आएगा बताओ? 2 pi खत्म, minus 2 pi cos theta. Cos theta definition क्या आता है? Minus sin theta. Minus minus will, so it will be 2 pi sin theta. So from here, this is what we have to use every time. That d omega is equal to 2 pi sin theta d theta. Even in this chapter, this is only which is relevant for us. That what is d omega, we can write it as 2 pi sin theta d theta. Everyone comfortable with this?
Yes, sir.
Now coming to this topic. See, what I am doing, I am just dealing the few details of Rutherford scattering in chunks, and then I will combine all of them. It will be more easy to understand. Next is differential cross-sectional area. Anyone who can define it? What is differential cross-section area? What is differential cross-sectional area? What is differential? What is differential? Chota sa? Yes, no. Differential is what? Very, very small. Cross-sectional area is area. So let me tell you one thing. What will be unit of this?
Unit of area.
Are you sure?
Most probably.
Yes. So unit will be area. Yes, it is area, so it will be area, meter per square. Here. Chalo. So let us understand this concept first. What happened that we have a target. I hope everyone has learned few idea about Rutherford scattering in their school classes. पता था ना कि that we take a thin sheet of gold, right? These are my nuclei. These are my nuclei that I am making. Thin sheets of gold, in which we have projected alpha particles. सुना है कभी?
Yes, sir.
ठीक है? So understand. So let's say these are my beam of alpha particles. अच्छा, एक अल्फा पार्टिकल और एक एटम लेते हैं क्या, या मल्टीपल अल्फा पार्टिकल मल्टीपल न्यूक्लियस होता है? उसका अप्रोक्सीमेट वर्जन पढ़ लेते हैं हम लोग मैथमेटिकली के लिए. क्या एक ही बीम होता है या मल्टीपल बीम होता है? हम लोग अपने मैथमेटिकल ईज के लिए कुछ कम कर लेते हैं. tell me, when we do any experiment, do we have multiple nuclei? अरे एक शीट लोगे तो उसमें बहुत सारे न्यूक्लियाई होगा ना? Yes or no?
Yes, sir.
Yes.
And we will be having multiple alpha particle, right? So this is
Yes.
one of the assumption I will make you write down. ठीक है, टेंशन मत लो. But now try to understand this thing. So let us try to understand. एक को पकड़ लेते हैं किसी एक में से, ठीक है? So what all possibilities these particles are having when they are bombarded? ठीक है, they are being bombarded here. They are being bombarded here.
तो कुछ स्कैटर हो जाए और कुछ डायरेक्ट सीधे चला जाएगा सर।
Yes, very good. तुम लोग बोलोगे कि इसमें से कुछ जो है वो पीछे आ जाएगा, नो 0 डिग्री पर डिफ्लेक्ट करेगा. सम ऑफ देम विल गो विदाउट डिफ्लेक्शन. अब व्हाट विल बी द number of particles? That doesn't matter. Let's say we are sending 1 million. 1 million means 10 lakh particle. Might be from 10 lakh particle, only 100 particle are coming back in this direction, and only 500 particles are coming back in this direction. That's a matter of debate, right? But these are the possibilities. Yes or no? These are the possibilities that the angle made here, it will be how much? 0 degree. And angle made here will be equals to pi. Apart from this, what all possibilities are there? Few will go deflected in this direction, 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 and few will go deflected in this direction. I hope everyone is understanding this thing. इस समझ में सबको आ रहा है कि मैं क्या बोलना चाह रहा हूँ? Now understand this thing. This is my projectile. It is my projectile. And this is my target. Now, and they are bombarded on this thing. So consider it will have some intensity. It will have some intensity I. अरे what is intensity? What is intensity? सब लोग बताओगे मुझे.
सर इंटेंसिटी मतलब होता है नंबर ऑफ टर्न बढ़ जाते हैं. जैसे फोटॉन की बमबारी कर रहे हैं, अगर इंटेंसिटी ज्यादा होगी तो नंबर ऑफ फोटॉन बढ़ जाएंगे उतने ही टाइम में.
Very good. So intensity is basically defined as energy per unit area per unit time, or power per unit area, or power per unit area. This is how we define as intensity. How intense it is, it depends upon under what area you are putting how much power. Now energy is a function of what? It is a function of, in case of subatomic particles, normally let's say photon, alpha particles, right, or electron, energy is quantized. Have you heard about this thing? So energy is the measurement of number of particles. So I can say that, just you have said, Sudhir, that number of particles, it depends upon number of particles again. Per unit area per unit time. जिसे हम लोग कई बार फ्लक्स भी बोल देते हैं. Do not get confused in these things, right? It is also known as flux. यहाँ तक clear है सबको, right? So when we are bombarding any particle, what does matter? What does matter? I depends upon what? number of particles bombarded. Number of particles bombarded. I think everyone agree on this thing that I intensity depends upon number of particle bombarded. If you increase the number of particle, the intensity will increase. Considering this small strip of the target. Considering this small strip of the target. So if the area is fixed, unit is fixed. So if you increase the energy or the number of particle, then its intensity will increase. Yes or no? I am keeping the time as well as area as fixed. Unit area, unit time. We are missing. Now, what I am doing now, I am now making one detector. What I will be doing now, I will be making one detector.
जिंक सल्फाइड का होता है सर.
हाँ?
जिंक सल्फाइड लेते हैं सर. जिंक सल्फाइड.
जिंक सल्फाइड लेते हैं? जिंक सल्फाइड क्यों लेंगे?
सर पता करते हैं ना कि वो स्कैटरिंग कहाँ हो रही है, मतलब पहचानने के लिए.
जिंक सल्फाइड इसलिए लेते हैं कि हम उसको ऑब्स्ट्रक्ट कर सके. फॉर द ऑब्स्ट्रक्शन वी यूज जिंक सल्फाइड. वो कहां से आ गया यहाँ पर? we are only seeing the mechanics of that thing. समझ आ रहा है?
ओके सर.
ठीक है. मैं बस क्या बोल रहा हूं कि यहाँ पर हमारे पास एक टारगेट न्यूक्लियाई है और यहाँ पर मेरे पास प्रोजेक्टाइल है. जितना नंबर प्रोजेक्टाइल का बढ़ेगा उतनी ज्यादा इंटेंसिटी बढ़ेगी, ज्यादा एनर्जी बढ़ेगी. क्लियर है? या फिर अगर मुझे पता है कि इंटेंसिटी इतनी है, इसका मतलब है कि नंबर ऑफ पार्टिकल मुझे पता है ऑलमोस्ट. ठीक है? क्लियर इतनी बातें? नाउ वी हैव वन डिटेक्टर हियर. दिस इज माय डिटेक्टर. And this detector will move. ठीक है? It can move. This is my detector and it can move circularly. मतलब it can move. समझ आ रहा है? ये घूम घूम कर हर एक एंगल पर डिटेक्ट कर सकता है. Right? Now, let's say for this particular instant, if it has to detect something, so what he will do? Number of particle which is coming here. मैं इसके बीच में हटा देता हूं. Number of particle which is coming here. Now, if you see here, can everyone see that it is a 3D? So in which we will be having a d omega, and this d omega, in this d omega we will be having dn. What is dn? Let me write it down. So dn is equals to number of particles collected in detector. Number of particles collected in detector. ठीक है? And let us write down nt. nt I am defining number of target particles. Number of target particles. अब मुझे कुछ चीजें बताओ. ठीक है? समझना अच्छे से. What is this? हाँ.
What is the meaning of target particles?
These are target particles.
Okay.
Have you joined late?
Yes.
Okay. In the last, have you seen the last class?
Yes.
So in the last class, we have discussed about this thing now, scattering. Scattering is something in which we have two particles, right? One particle is bombarded on the other particle. The particle which is bombarding is known as projectile, and on which we are bombarding it is known as target particle. So basically, there are two mass system of collision, elastic collision we are talking about. Okay?
Okay.
This is just a way of representing it. Now tell me one thing. That this dn is what? Number of particle collected in the detector at a certain interval of time. इसका जितना बड़ा mu होगा, उतना ही बड़ा तो इसका सिग्मा बनेगा, सॉरी ओमेगा बनेगा, एंड उसी के बेसिस पे ये डिटेक्ट करेगा। तो एट अ पर्टिकुलर इंटरवल ऑफ टाइम, यही तो बोला गया है, per unit time, per unit area. So at a particular interval of time, this dn is the number of collected, right? So can anyone tell me, can I write this thing that dn will be proportional to I? Yes, no? Array, I is what? I is my input, or number of particle thrown. So higher the number of particles thrown, higher will be the probability of getting detected.
Yes.
Yes or no? भाई यहाँ पे
Yes.
क्या कितना पार्टिकल बाहर निकला, तो तुम मान लो 5 पार्टिकल फेंकोगे तो उसका 2 पार्टिकल निकले, अगर तुम 10 पार्टिकल फेंकोगे तो 200 ज्यादा ही निकलेगा। yes or no? So the dn depends upon I, first thing. Second, and
सर ये एंटी सर अपना नंबर ऑफ टारगेट पार्टिकल्स होगा या नंबर ऑफ पार्टिकल थ्रोन होगा?
नहीं, नंबर ऑफ टारगेट पार्टिकल है, नंबर ऑफ पार्टिकल थ्रो तो इंटेंसिटी नहीं ना,
हाँ सर।
इंटेंसिटी में तो टाइम और एरिया को फिक्स करो तो नंबर ऑफ पार्टिकल ही है जो थ्रोन हुआ, ठीक है। Okay. Now, can I say that dn is also depends upon d omega? ये
Yes.
इतना छोटा है तो इतने पार्टिकल्स को लेगा, अगर ये और बड़ा हो जाता तो और लेता, ये और बड़ा होता तो ये और लेता, राइट? तो dn
Yes.
is proportional to d omega. बहुत अच्छे से समझना, ये बहुत इंपॉर्टेंट टॉपिक है, यूपीएससी वन ऑफ द फेवरेट टॉपिक इज दिस, ठीक है। व्हाई दिस इज व्हाट इट इज, ऑब्जर्वेशन sphere. Just like sample size, when we increase the observation sphere, dn will also increase. Same thing. And last thing, what is the relation between dn and nt? dn और nt में कोई रिलेशन हो सकता है क्या?
Sir, they should be directly proportional.
सर हो तो सकता है, मतलब एंटी सर जितना ज्यादा होगा उतना होगा।
They should be directly proportional. Why? Nt is representing what? Interactions. So number of interaction will increase, it will also increase. Yes or no? Number of interaction will increase, it will also increase. Now, one way of visualizing it is just like समझो, what is happening? Projectile is coming, projectile आ रहा है, right? टारगेट पार्टिकल से टकरा रहा है, इसको समझो, हमेशा दिमाग में ये रखो, ये फिगर रखोगे, इसी का हमने इलॉबरेटेड बना दिया है, ठीक है। अदरवाइज वी आर डूइंग मैकेनिक्स, सो वी विल अगेन शिफ्ट आवर फोकस टू हियर, अभी जस्ट कर लेंगे, बट ट्राई टू अंडरस्टैंड दिस थिंग। एक पार्टिकल आया, इससे टकराया और डिफ्लेक्ट हो गया, दैट मींस दिस प्रोजेक्टाइल इज कमिंग, hitting the target and it got deflected. Now understand, consider this as ball, this as bat, right? And dn is catch out, and d omega is our observation, that is fielder, that is fielder, ठीक है। लेट्स से इसको बॉलर कह लो, बॉलर हु इज बॉलिंग, batsman who is hitting, and in this game there can be number of bowler, number of batsman, number of fielder, number of bowler, number of batsman, number of fielder. I am only interested in ki how many catch out we can have, so it will depend upon how many balls are thrown first. Higher number of balls will thrown, higher number of probability of catch out will be there. Batsman, number of batsmen will be more, there is more probability of deflection and shot hit by the batsman, and then number of fielder, higher number of fielder, that means higher probability of catching out. अरे ये समझ में आ रहा है ये एनालॉजी सबको? यही तो है, समथिंग इज थ्रोन, एक है जो हिट कर रहा है, तो टारगेट इज हिटिंग इट, राइट? सो द अगेन सी द नंबर ऑफ इंटरेक्शन विल इंक्रीज when NT will increase. So if you combine all of them, we can simply write that dn is proportional to int d omega, int d omega. Now what we introduce now, please try to understand here. ठीक है, this proportionality sign has to be removed by a constant, right? So I am writing here dn is equals to d sigma, ठीक है, बाई डी ओमेगा। थोड़ा सा लिख के लग रहा होगा कि ये कांस्टेंट किस तरीके का लिख रहे हैं, है ना, बट इट इज कांस्टेंट, अज्यूम इट, एंटी ठीक है। और अगर तुम्हें इसमें तकलीफ होती है तो तुम उससे ऐसे लिख लो, सिग्मा ओमेगा, ठीक है, सिग्मा ओमेगा, दोनों ये लिख लो, सिग्मा ओमेगा इज डी सिग्मा बाई डी ओमेगा, एंटी इंटू obviously this sigma omega has to be a constant quantity, and this is what we known as differential cross section area. Please watch it. How many of you are studying for the very first time this thing, differential cross section area? सब लोगों ने पढ़ रखा है पहले से? See, this topic is something which people find it to be a tough one, ठीक है? There are almost 5 to 6 topic जिसे लोग टफ बोलते हैं मैकेनिक्स पोर्शन में, so it is one of them. That's why I'm going a bit slow, ठीक है, and telling you all the things. So sigma phi, sigma omega और d sigma, we define it as differential cross section area. Differential cross sectional area. Now, and to understand this thing, right? This thing has got beautiful meanings. The first meaning that you should understand that it is an area, okay, and it is used as a constant. So it is a constant quantity for a defined set of interaction. It is a constant quantity. First thing that you have to mention, because we have used it as a constant, we have removed the proportionality and we have used this one. So it is working as a constant. Okay. Now, second thing, can I write as it is an area, so it is just a geometrical property. So if it is a geometrical property, it is independent of elasticity. अरे तो ऑब्जर्वेशन बेस्ड चीज है, so it is independent of elasticity, whether it is elastic collision or inelastic collision, it doesn't matter. It doesn't matter here. It is a geometrical property. It is independent of the elasticity. And the third thing, it tells us about the probability of interaction or scattering. It tells us about the probability of interaction or
सर
distance.
लाइक
हाँ.
एरिया ज्यादा है तो प्रोबेबिलिटी ऑफ इंटरेक्शन ज्यादा होगा ऐसे.
Yes.
ओके.
लिखा होगा.
सर अभी आपने जो एक एग्जांपल दिया ऊपर वो कैच आउट वाला,
पहले ये लिखवा देते हैं, ठीक है. Higher the sigma omega, higher will be the probability. Higher the sigma omega, higher will be the. See why we are saying so. सुनना चाहिए पहले, ये मुझे एक्सप्लेन करने दो एक एक चीज को. फिर constant quantity as you have seen, because from these things we have come to this equation, so it has to be constant. Geometrical property, because it is an area, ultimately we are getting something in terms of area independent of elasticity. This is you need to understand. See, again we are saying that it is a constant geometrical property, then no matter, and I will show you also, ठीक है. ये अभी आगे तुम्हें दिखेगा अभी in numerical hard stress scattering. I will prove that this is how it is a geometrical property, and when something is a geometrical property, elasticity doesn't matter. Although we consider most of the cases that elastic collision, but again it is not, even it is not that, it will not change. It is just like that we are more comfortable mathematically in elastic collision, that's why we do so. ठीक है. Third point. Fourth point, it is the probability of interaction. Obviously it depends upon anything. रुक जा.
लेकिन
बोलो.
लेकिन जो इस लेवल पे मतलब एटॉमिक लेवल पे कोलिजन्स होंगे वो सारे इलास्टिक ही होंगे ना.
मोस्टली इलास्टिक ही होते सारे.
सर व्हाई मोस्टली देयर ऑल कोलिजन्स आर इलास्टिक ना at quantum level, like
Yes, see, understand. When you go into the relativistic domain plus quantum, at any point of time, momentum energy is always conserved. ठीक है.
yes.
But when we are doing in the mechanics section, we have to be open to our macroscopic world also, where friction also plays a
Okay.
role, where elastic or deformation of things can also happen. समझ में आ रहा है?
हाँ.
मैंने बताया था ना कि मैकेनिक्स की डोमेन मैक्रोस्कोपिक है. क्लियर है? So that's why we are writing mostly interaction. When you go into the quantum level
Okay,
or even into the relativistic domain, every time energy will be conserved. We will be seeing in the coming future. ठीक है? Okay, got it? चलो अब जो
Yes.
पूछे थे वो पूछो. ये समझ लो पहले. It is about the probability of interaction. Why? Because it depends on NT. Higher the number of NT and I, this coordination will be higher if DN has to be higher. Yes or no? That means high probability of scattering. पूछो पूछे थे जो पीयूष.
सर जैसे कि अभी आपने बताया वो कैच आउट वाले से, उस वाले से तो सर समझ में आ रहा है मेरे को कि आई ज्यादा होगा, फील्डर ज्यादा होंगे, बैट्समैन ज्यादा होगा. लेकिन अगर एंटी बहुत ज्यादा हो जाए सर, तो वो तो एक तरीके से पूरे पार्टिकल्स को जो आ रहे हैं अपने मतलब बॉम्बार्ड किए, वो तो एक तरीके से रोक ही देंगे ना अगर एंटी बहुत ज्यादा हो जाए तो.
सुनो, एंटी का काम रोकने का नहीं होता है, समझो इस चीज को. एंड व्हेन वी से दैट न्यूक्लियस ऑन एटॉमिक लेवल, ठीक है, तो फर्स्ट ऑफ ऑल अपन जो हम लोग बात करेंगे तो हम लोग बात करेंगे सिंगल पार्टिकल. बट अगर मल्टीपल पार्टिकल है और जब हम लोग बात करते हैं सब एटॉमिक लेवल पे, तो दे आर इनफ स्पेस बिटवीन टू न्यूक्लियस. समझ में आ रहा है? दो न्यूक्लियस के बीच में बहुत बड़ा स्पेस होता है.
हाँ सर मैं मतलब लेकिन उस तरीके से सोच रहा था कि मतलब जैसे कि एक बॉल आ रही है, फिर अपन ने यहाँ एक या दो बॉल बड़ी बड़ी रख दी, लेकिन फिर अगर सर बहुत सारी रख देंगे फिर तो निकल ही नहीं पाएगी ना अपनी बॉल. ये मैं इस तरीके से विजुअलाइज करने की सोच रहा था.
विजुअलाइज ऐसे करो कि लगातार पिच बनी हुई है, बहुत सारी पिच है और हर पिच पे बैट्समैन है, बॉलर है. तो जितनी ज्यादा वो पिच होगी उतनी ज्यादा प्रोबेबिलिटी है कैच आउट होने की.
हाँ सर इस वाले एग्जांपल से तो हाँ मतलब समझ में आ गया.
दिस इज वन गोला. यहाँ पे बहुत सारे पिच है जिसमें बैट्समैन और बॉलर बैटिंग कर सकते हैं, राइट. और इसके बाहर सब हिट कर रहे हैं और इसके बाहर एक सर्कल है जहाँ पे सारे फील्डर खड़े हैं. ठीक है. देखो जहाँ पे चीजें थोड़ी सी क्लासिकल एज वेल एज क्वांटम डोमेन में जाती है ना, तो इंट्यूशन इतना काम नहीं करता. समझ आ रहा है?
हाँ सर कोई इंट्यूशन मतलब आ नहीं रहा था मेरे को ये एंटी वाले टर्म से, लेकिन अब ठीक है. हाँ सर
ठीक है. दिस इज व्हाट यू नीड टू अंडरस्टैंड. क्योंकि देखो वी हैव टू जस्ट सी कि डिफ्लेक्शन कितना हो रहा है. तो नंबर ऑफ इंटरेक्शन विल इंक्रीज, deflection of particle, possibility of deflection will be also higher. Yes or no?
Yes sir, yes sir.
This is, we are always, देखो हम क्या लिख रहे हैं, probability, possibility, all those things. अगर एक ही पार्टिकल है और ये आया तो ये आएगा, ऐसे निकल गया है ना. बट अगर यहाँ पे हम लोग पार्टिकल के नंबर बढ़ा दिए तो ये भी पॉसिबिलिटी है, ये भी पॉसिबिलिटी, ये भी पॉसिबिलिटी, ये भी पॉसिबिलिटी है, ठीक है।
यस सर, ठीक है।
Both the target particle are there, and if I'm throwing for the first time, तो हो सकता है कि ये ऐसे निकल जाए। If you throw one particle second time, हो सकता है वो ऐसे निकल जाए। If you're throwing third particle, हो सकता है ऐसे निकल जाए। So same goes with both of them. Both way it works. Okay?
ओके सर।
सर ये डी सिग्मा क्या है?
Yeah.
ये डी सिग्मा क्या है?
D sigma.
डी सिग्मा अपॉन डी।
Sigma is total cross section area. अभी आ रहा है, सर पे आ रहा है, इसको ऐसे भी सकते हो, ठीक है। It can be
अच्छा
also-
सर, ये लास्ट वाला फिर से एक बार समझा दीजिए कि प्रोबेबिलिटी कैसे बताता है कि ज्यादा होगा तो हायर चांसेस है इंटरेक्शन के।
हम dn को ऑब्जर्व कर रहे हैं, है ना, वी आर ऑब्जर्विंग dn, so the higher number of dn, the higher number of this we will found, yes or no?
कैसे सर? सर ये सिग्मा समझ में नहीं आया, सिग्मा है क्या?
मैं अभी आ रहा हूँ, सिग्मा पर ही आ रहा हूँ। डी सिग्मा बाई डी फाइव, इसको मान लो कि डिफरेंशियल क्रॉस सेक्शन एरिया है, और इसका काम ये बताना कि कितनी प्रोबेबिलिटी हो रही है इंटरेक्शन की, ठीक है। दिस इज द मेजरमेंट हाउ वी डू दैट, ठीक है। अभी आ रहा हूँ मैं, अभी गिव मी जस्ट 2 minutes, ठीक है। लेट मी कंप्लीट दिस थिंग, देन यू विल गेट द आइडिया ऑफ सिग्मा, ठीक है। देन हो सकता है तुम उसकी डी सिग्मा को भी समझ पाओ, ओके।
यस सर।
नाउ if I write here d phi by d omega, if it increases, this means that dn will be also increasing. पहले तुम्हारी बात को कर लेते हैं। From here, let's say if intensity is same, nt is same number of particle भेजा गया है, right? And if this is increasing, can I say that it will also increase?
यस सर।
Right? What is dn will denote? Or leave about that. If I is constant, nt is constant, and I have placed the detector there, ठीक है, same, सबको same, and dn is increasing. If dn is increasing, can I say that this is also increasing?
यस सर।
And this parameter we are associating with possibility of interaction. Why? Because dn depends upon interaction. Higher the number of interaction, higher will be the dn that we will get. Okay.
Yes.
So it means simply that probability of interaction increases. ठीक है। Also you can write it that d sigma by d phi, it is sometimes written as sigma omega like this. That means probability at a certain angle. This is what we are writing theta phi for what? Spherical domain, ठीक है। This you can. Now few things I want you to write it down. First one is its application. There are few topics जिसकी value addition में class में ही करवाऊंगा, which is very important, ठीक है। So it helps in subatomic is what? Nuclear and atomic physics. Example बताया था मैंने, like discovery, of neutron, nucleus. Second, helps in low energy physics. We will study in solid state. बताया है कि few things you have to mention here so that you can make cross connection when you will study these topics. ठीक है, जब तुम ये टॉपिक्स को पढ़ोगे तो क्रॉस कनेक्शन बना पाओगे. सॉलिड स्टेट, ठीक है.
Sir, relating to Bragg's law, etc.
यस. न्यूट्रॉन स्कैटरिंग वो भी लिख लो. दैट इज एक्स-रे स्कैटरिंग, ब्रैग्स लॉ. Now, what I have told you already in the initial lectures that few things we will be doing that will become more clear, or application will more clear when we study these things. So these things we have to study, right? There it will become more clear because their application will be more. Okay. As of now, you have to understand that it is the probability of interaction. Why? Because it directly depends upon dn. dn is what? Number of particles that we are getting. The number of particles that we are getting is dependent upon all the interaction, bowler, batsman and fielder. है ना? So it is related to that. What is the assumption? Or limitation? There are various assumption limitation. First thing, although we are understanding in terms of this, but we will write it for single projectile or incident particle. Second, because अभी हम लोग देखेंगे cases, in all of the cases you have to assume these assumptions. Second, single target particle. Third, interaction is same and available for all particles. So we are doing it for one particle and then we are saying that this interaction is same. That means every interaction is alike. एक जैसा है सब कुछ. So that's why we will be able to talk about all the things. Clear? Note, it note here. Always write these assumptions in your answer. See, these are something which are not very intuitive, okay? But still we have to manage that how we will understand it and write it down. Okay? This is काम बन जाए. This is what we should aim for. Now, I can write here or d sigma by d omega. D sigma by d omega. क्या लिख सकते बताओ? What we can write? अरे यहाँ से लिख दो ना. क्या आएगा? d sigma by d omega. dn by d omega.
सर ये डी ओमेगा फॉर्मूले में कट नहीं होगा ऊपर? ऊपर से डी ओमेगा नीचे आ रहा है डी सिग्मा बाय डी ओमेगा एन टी आई डी ओमेगा.
नहीं कटेगा, डी से उतर क्योंकि वी आर नॉट इंटरेस्टेड फाइंडिंग डी सिग्मा। डी सिग्मा बाय डी ओमेगा इज द टोटल क्रॉस सेक्शन एरिया। ठीक है,
सॉरी सर, क्या बोले सर आप? इज इक्वल्स
इज
टू?
माय टोटल क्रॉस सेक्शन एरिया सिग्मा। ये कंप्लीट टर्म को ही हमने डिफाइन किया है डिफरेंशियल क्रॉस सेक्शन। ठीक है, इसलिए निकाला।
और सर यही सर पॉसिबिलिटी बता रहा है, मतलब पॉसिबिलिटी वाला जो फैक्टर है।
अल्टीमेटली एक चीज और समझ लो, ऑल्दो its dimension is of meter square, but its unit is meter square per stair area। समझ में आ रहा है? डिफरेंशियल स्क्वायर एरिया की जो यूनिट होती है वो मीटर पर स्क्वायर स्टेयर एरिया होती है। ठीक है, बट खैर वी कैन मैनेज विद द मीटर स्क्वायर, डजंट मैटर मच है। सो इट इज व्हाट dn, इसमें बहुत सारे assumptions है, प्लीज ट्राई टू लुक फॉर द कॉन्सेप्ट एंड देन वी माइंड dn by d sigma, then 1 upon int, 1 upon int। ठीक है, if nt is 1, then we can write, if nt is 1, एक ही nt हो, then we can write what, ऐसे लिखो सिग्मा ओमेगा। ठीक है, इट विल बी इक्वल टू 1 by i, हाँ 1 by i please write the underlined assumption every time। इसको इंटरप्रेट करके बताओ। So this is nothing but what, number of particles scattered per unit time per scatterer per solid angle। वही तो है, dn is the number of particles scattered per unit, all those things। Second, or some number of particles scattered per unit solid angle per incident flux, per incident flux। or there is a one more way of writing it down, is that we are observing all those things into d omega। So probability of finding the scatterer in d omega, probability of finding the scatterer in d omega। समझ आ रहा है थोड़ा थोड़ा? इवन इफ इट 70% क्लियर, मेरा काम हो जाएगा फिलहाल के लिए। Then write down total cross section area। इसको फिर से एक बार रिवाइज करेंगे हम लोग, टेंशन मत लो। टोटल क्रॉस सेक्शन एरिया, व्हाट इज टोटल? टोटल आई कैन सिंपली दैट कि सिग्मा इस पूरे एंगल पे, दैट इज सिग्मा ओमेगा डी ओमेगा, इंटीग्रेट कर सकते हैं हम लोग, which is equals to sigma theta। Can we convert it? What was d omega? याद करो, 2 पाई क्या आया था? sin theta d theta
D
from 0
theta.
to this we can use for our cross section area. This is the complete cross section area. Complete cross section area, and it will tell us whether we should choose this interaction or not. Whether we should choose this interaction or not. Okay? It gives the condition of interaction or verdict or probability of the complete interaction.
सर
सुनो, हाँ बोलो।
हाउ मतलब कैसे कैसे करता है?
Again, it is from an analogy I can tell you. सुनना। Let's say we are working in law department of India, and we have multiple agents, and we are sending them into Pakistan, right? And till the time they are in the Pakistan, we don't have any such contact, right? The time when they will return back to India, then we can have the informations. ठीक है? यहाँ तक clear है? So
Yes.
tell me which of the mission is successful, in which most of the particle will come back and tell us the information. Yes or no?
Yes.
Two things are there. Most of the people should come and tell us the information. If no one comes, then it is also an unsuccessful mission. If everyone comes without any information, then also it's an unsuccessful mission. Yes or no?
Yes.
Now, consider what we do in a solid, just basic understanding. Solid, solid objects are arranged in layers. Do you know that? And
Yes.
if I send one particle here, and after coming back from the solid, by somehow it will tell us the gap between these layers. This gap between these layers will enable us to write down its structure. That means the coming particle has the information, how has this interaction be, right? So what should be my
Yes.
aim? That the maximum number of particles should interact with the lattice, solid lattice, so that we will be able to find out the average observation. समझ रहे हो मैं क्या बोल रहा हूँ?
Yes.
मान लो पहला पार्टिकल आया, वो बोला कि 10 मीटर है गैप, दूसरा आया वो बोला कि 10.2 मीटर है, तीसरा आया वो बोला 10.4 मीटर है. So the large number of particle will come out with their values. I will be able to more accurately find it. Yes or no? So this is what we mean by total cross section area, right? If the total cross section area, it's a mathematical parameter. Mathematically, if it is a high quantity, then we can say that the probability of this interaction is higher, or it is more feasible interaction. That means it will have more information about that system. Clear hai? Everyone? It is about the complete interaction. Now, let us find out again. This is our map of India, let's say, right? We have Rajasthan, we have Gujarat, we have Kashmir, we have Punjab. All of them share border with the Pakistan, and from each border we have sent our agents. Yes or no? So if you want to find the total cross-section area, total information, we have to combine, integrate all of them. But if we move from, again, this say Kashmir, from Punjab, then Rajasthan, then Gujarat, right? Then small patches, let's say Atari border, right? This is my d sigma, d omega. And this d omega will have a certain small information that we are writing it here, probability of finding the scatter in d omega or differential cross-section area. Understood everyone?
Yes.
देखो जो क्वांटम वाली चीजें है ना, जहां पे भी थोड़ी बहुत ऐसी चीजें आती है जहां पे तुम डायरेक्टली रिलेट नहीं कर सकते हो. देखो मैकेनिक्स में 90% चीजें क्या है, आदमी है, घोड़ा है, गाड़ी है, तुम समझ जाओगे हाँ एक बॉल से मारा, बॉल लगी और वो गिर गया, ठीक है. इट इज वेरी इंट्यूटिव to imagine or understand. But when you go into the quantum level, तुम्हें ऐसी ऐसी जो मेंटल इमेजेस और जो मैं कहानी चाहता हूं उससे तुम्हें थोड़ा सा कोरिलेट करना होगा समझने के लिए। प्लीज रेज योर हैंड इफ एवरीवन हैड अंडरस्टूड दिस पॉइंट एंड आई वांट टू सी फ्रॉम एवरी वन ऑफ यू। जिसको डाउट है अभी पूछ लो, बिकॉज दिस इज द वेरी इंपॉर्टेंट, मोस्ट इंपॉर्टेंट। अभी के बाद सिर्फ डेरिवेशन है, कोई दिक्कत नहीं होती है इसमें, बच्चों को मजे से करते हैं लोग। Those who have understood, please raise your hand. Otherwise, ask the doubt. चलो ठीक है। नेक्स्ट राइट डाउन समथिंग विच इज नोन एज इम्पैक्ट पैरामीटर। आई होप ये तुम सबने सुना होगा। Also in your class 12 syllabus, impact parameter. Anyone want to describe? देखो एटलीस्ट ट्राई करो। एग्जाम में तो ट्राई कर नहीं सकते हो, बट क्लासरूम तो है ना जहां तुम एक्सपेरिमेंट कर सकते हो।
distance between target particle and
यस यस कैरी ऑन, सही जा रहे हो।
सर मैथमेटिकली पता है बी होता है।
सही जा रहे हो तुम ऐसे। बाकी और कोई बताओ, ट्राई करो ट्राई करो। सी देखो मैं तुम्हें एक चीज और सबको एक्सप्लेन करता हूँ। इफ आई वांट टू मेक दिस इंटायर कोर्स, ठीक है, इन अ मोनोलॉग सेशन, जो मैं बोलूं और बिना टाइम दिए आगे निकल कर खत्म करवाया जाए सिलेबस, so it can be easily done in 250 to 300 hours. Why 300 hours? Because I teach more. The content that I taught is more than what is taught standardly. ठीक है, but all the time that I give you for thinking or dialogue conversation, please try to involve in that, because it will, see, I have already told you that after this year also many students came and they asked that what they will ask in the interview for physics. I don't have the way of explaining that. So you should have a way of explaining in a very simple word, because the panel will not be physicist. So this should be imbibed in you, right? ये पूरे साल का रहता है ये चीज, ठीक है? तो प्लीज ट्राई करो। एंड हाउ इट विल बी बिल्ड व्हेन यू ट्राई टू स्पीक इन द क्लास, ठीक है? Minimum distance between the interacting particles. Okay, very good. Very good, Shubham. Or koi? So he has said right? Just one more condition that we have to add, that impact parameter is the I hope everyone is taking their notes, है ना? And also leaving some spaces for validation. To which a projectile can approach the target if there were no forces that is assumed between them. So let's say this is my target and this is my projectile, right? The minimum separation here is B. And at this point of time, we are saying no forces. Why? Can anyone explain this thing? Why I'm saying no forces? Because it is at a very large distance. Now you need to understand. Usually used in scattering. Impact parameter is something which is usually used in scattering. Okay. See, always try to balance out the statement by saying usually, generally, because they are something.
Because force can influence the trajectory projectile to get near.
Exactly. So if they are at very large distance, we are assuming there are no forces. See, all the forces in nature are somehow either they are contact based or non-contact based. When they are non-contact based, they are definitely distance dependent. So every force in nature is distance dependent. Contact means what? The distance between them is zero. There is no distance between them. So otherwise, you need to understand that when the distance between the particle increases, their force decreases, be it any force in the nature. So every force in the nature is distance dependent. So if we assume a very, very large distance between them, the maximum height at which it can have, it is P. Now we have to assume scattering. When we write impact parameter, the assumption is what? We are using it for scattering, mostly in the case of scattering. So what happened? This start increasing because it get now deflected. When it start moving with, let's say V, the height, are you seeing it? This height is getting increased. So the minimum distance between the projectile, how we calculate the minimum distance? The center of the target to the center of the this. ठीक है? Minimum distance कैसा होगा ये? Minimum distance means, although we consider it as point particle, but it should be center to center. कई बार क्या होगा कि तुम डायग्राम बना रहे हो तो डायग्राम में it will help. This for diagram, but otherwise we are considering is a point particle. Now understand this thing. यहाँ तक clear सबको? So I am reconsidering this thing. Now if it go undeflected, give me a minute, otherwise पूरा बर्बाद जाता है. ठीक है? Yes. If it go undeflected, it will go something like that. Yes or no? But what will happen? होता क्या है?
It changes its trajectory in parabolic way.
So let's say it
Sir,
changes.
is it always parabola or?
It is hyperbola.
Oh, sorry, hyperbola.
खैर, we are interested कि this is going to change its path, है ना? Is going to change its path. Now I am considering, let's say, at this angle. This is my d theta, right? So it will change its path something like this. ठीक है? Now एकदम अच्छे से समझने की कोशिश करो. This is very, very important to understand. Let us write the parameters. So can I say that at this direction, this angle, if this angle is theta, I can take this as d theta, right? And this d theta will certainly corresponds to d omega in 3D. This d theta will certainly corresponds to d theta in this. ठीक है. Now few parameters I am writing here. Now tell me everyone, if B is equals to 0, then what will be theta?
pi.
Pi.
Hmm.
It will go, hit and come back. If B changes to infinity, then what will be theta?
0.
0. Very good. Everyone understanding it or not? अगर ये बहुत दूर होगा तो डिफ्लेक्टेड ही नहीं करेगा. Yes or no? चलो. Now, if you guys understanding this thing, let us understand. Can I make a circle here? And can I make one more circle here? So it is just telling me अरे बन जा भाई. चलो जो भी है, not so good, but it will work. Let's say at when particle is deflecting from in this category d theta, that means its impact parameter has also got changed. The impact meter also got changed in this shape. That means the width here is dB. Width here is dP. That means when there is a change of dV in impact parameter, there is change in deflection by d omega. There is change in deflection by d omega. Everyone getting it or no? ये सबको समझ में आ रहा है? Now, what will be this area? If dB, if I write in terms of area, what will be this area? dA.
2 pi b dB.
Very good. It will be 2 pi. It will be 2 pi dB. Now, how we can relate this with sigma or theta? How can we relate?
Both are directly proportional. Sorry, theta and A are directly proportional.
Theta and A are directly proportional.
Yes.
dn, dn is equals to what? I can write I into dA. Small incoming particle. Yes or no? I am just saying that dn is the number of incoming particle, and I'm assuming कि सारा निकल जा रहा है. Number of outgoing particle. So we have two formula. Using those two formula, I'm writing here. अरे यहाँ से क्या रिलेशन आ रहा है B और थीटा में? When B is increasing, theta is
decreasing, sir.
So for a safer side, we will write dn is equals to I into dA की वैल्यू क्या लिख देंगे? 2 pi B mod dB. And when it is positive, it is positive. This is for my incoming. Let us assume that both of them are equal. Assuming both of them are equal. जितना आया उतना पूरा पूरा चला गया. Obviously, yes or no? Because the number of particles that will come, it will go whether at किसी भी angle पे जाए, but it will go certainly. It is equal to what? Sigma into y. यही है ना? देखना एक बार. यही है ना फॉर्मूला ऊपर देखो. For a single particle. Yes or no? अरे yes, no.
Yes, sir.
What is this? We can write. Can I write it as into 2 pi sin theta d theta into I? बस इक्वेट कर दूं?
सर इसमें सर डी सिग्मा नहीं आएगा सर, ये दूसरा डी एन जो लिखा है।
फॉर अ पर्टिकुलर सिग्मा वी आर राइटिंग ना, क्या लिखा है ना हमने?
जैसे
थीटा पे लिखा है ना हमने। एक मिनट, सिग्मा क्या बोल रहे हो? ओमेगा?
यस सर, डी ओमेगा आएगा ना डी एन के साथ, डी एन इज इक्वल्स टू सिग्मा ओमेगा आई डी ओमेगा।
For a particular omega we are writing this thing, or this d theta we are writing it. This again we are writing for above this small thing. We have already encountered that thing. Clear? For d, that's why we take it as unity. Though this is a small thing that you should understand, that if you are fixing any parameter, we consider it as a unity. For every d omega, this is what we are writing.
ओके सर, मतलब डी ओमेगा को यूनिटी मान लो, ठीक है सर।
और else you can write dn per d omega, यहाँ पर dn by d omega. It's up to you. Clear है? If we do go into that mathematical method, clear ना?
ओके सर, यस सर।
यहाँ चाहो तो ये भी लिख सकते हो। I have defined ना कि from it is going from b to b, it is going from theta d5, we can write this number of particle is going. Now just equate them. So I can simply write that I into 2 pi b into db equals to sigma theta 2 pi sin theta, थीटा कहाँ से आ गया? अच्छा डी थीटा होगा ना यहाँ पे, डी थीटा इंटू आई। देखो क्या कट जाएगा, I will cancel out, 2 pi will cancel out. So can I write here sigma theta? This is the formula of sigma theta that you have to understand, or formula B. Can I write that it is B by sin theta modulus dB by d theta, or sometimes we can open this bracket and write B by minus B by sin theta dB by d theta. Why? Because when B increases, theta decreases. When B increases, theta decreases for this case. What is this sigma theta? What is sigma theta?
Total cross section area.
Differential cross section. Totally sigma only. It is dependent on theta, na? It is what? Differential cross section area. It gives us the probability at from theta to theta plus d theta. ये probability कहाँ से कहाँ देगा? Probability for theta to theta plus d theta, or if you go into 3D, omega to omega plus d omega, omega to omega plus d omega. ठीक है? Why we have written minus here? Because when b increases, theta is decreasing. Everyone clear with this? आसान था ये तो? Yes or no? No? Yes? जल्दी जल्दी बताओ, फिर आगे बढ़ा जाए. It
Yes.
might seem ये पहली बार पढ़ रहे हो, है ना?
सर एक मिनट ऊपर स्क्रॉल करिए और थोड़ा सा. सर ये नंबर ऑफ इनकमिंग पार्टिकल्स इक्वल्स टू नंबर ऑफ आउटगोइंग पार्टिकल्स, यहाँ से समझ नहीं आया.
Number देखो, we are saying that for a particular d omega, the number of particle which is going with this small circle, जिसकी impact parameter b to b plus db है, समझ आ रहा है ना? जिसकी b है वो किस पे रिफ्लेक्ट हो रहा है? थीटा पे, और जिसकी b plus db उसकी कितनी हो रही है रिफ्लेक्शन? थीटा प्लस d थीटा से, है ना?
थीटा प्लस डी थीटा. हाँ.
ये पार्टिकल b plus db से निकल रहे हैं, उतने ही पार्टिकल डिफ्लेक्ट हो रहे हैं थीटा से d थीटा तक. तो मैं उसी को बोल रहा हूँ. ये वाला पोर्शन मेरा इनकमिंग वाला सेक्शन है, कह लो, और वो आउटगोइंग का है, उसको मैं आउटगोइंग बोल रहा हूँ लूजली टर्म में. ठीक है? Incoming simply means the particle which has impact parameter from b to b plus db. If you want to write, everyone can write. Incoming particle, I mean that the particle which has the impact parameter from b to b plus db, and outgoing particle, I mean basically the particle which has deflection from theta to theta plus d theta. Okay? लिख दूं क्या? Having p from b to b plus db and having deflection theta from theta to theta plus d theta. Clear ना? जल्दी बताओ.
यस सर.
Conversion from lab frame to center of mass frame. अच्छा, when we go from a lab frame to center of mass frame, does number changes?
No.
Number changes? No. But does the scattering angle changes?
Yes.
So I can simply write that dn is equals to dn dash. Why? Same number as seen from both frame. This is pretty obvious. The same number will be seen from both frame. So I will be writing dn की value that I into sigma theta 2 pi sin theta d theta is equals to I into sigma dash theta dash. See, again, I is a parameter of number. 2 pi sin theta dash d theta dash. What will be the formula? Sigma dash theta dash, differential cross section area from the center of mass frame will be equals to sigma theta into sin theta d theta upon sin theta dash d theta dash. I think you know that. Scattering theta theta dash, you know, and sigma d theta is what? Differential cross section area in center of mass frame. It is in C frame. It is in N frame. Giving you 2 minutes. Please, जो भी पढ़ा है उसको देख लो एक बार. Then we will move ahead and start Rutherford scattering. Whatever the derivation that we have done till now, they have been already asked in the examination once or twice. I have few very good numericals on Rutherford scattering that we will be doing in our launch session. ठीक है? Launch 3, I guess. We will be doing very good questions. और जितने एग्जाम में आएंगे लोग बोलेंगे कि वो पक्का लोग छोड़ कर आएंगे और तुम करके आओगे. That I can guarantee. And that they might come anytime in the examination, because when you will study few topics, few modules, then I will tell you how the questions are evolving in each topic. Although these things we do in the last, then you will realize. Revise it. Chalo. Let's start with the Rutherford scattering. Now, from the बचपन you have studied this Rutherford scattering. कोई मुझे बताएगा क्या था ये? क्या ऑब्जर्वेशंस थे? अरे रदरफोर्ड थिन गोल्ड फॉइल एक्सपेरिमेंट यही था ना? पढ़ा तो होगा बचपन में यार, क्या बात कर रहे हो? That when an alpha particle is projected, on a gold foil, we have seen many observation that 1 in a million particle has just do the back scattering or scattered by pi or just reflected back. Most of the spaces are empty inside the nucleus. A few has only scattered. That means the nucleus is a positive. ये सब सुना है कभी कभी? Although this is not much required for that, but whatever the observations are there, it might help you in writing few of the conclusion. So observations, please do in your homework. 3-4 observations are there. Okay, 3-4 observations are there. You can also see it from the NCERT. NCERT में है, ठीक है? 3-4 ऑब्जर्वेशन थे कि न्यूक्लियस की डिस्कवरी ऐसी हुई थी, है ना, कि न्यूक्लियस बहुत ही डेंस है, न्यूक्लियस बहुत ही पॉसिबली चार्ज है, मोस्ट ऑफ दी जो स्पेस एटम में खाली है, ये सब सारी चीजें थी. If you want, you can do it. Otherwise, when we were doing the atomic structure in paper number 2, I will be telling you in the discovery of nucleus. Okay? Abhi, we are not interested in that. We are interested in the mechanical portion of that. Okay? Now, always write the assumption. I already told you. Assumptions, very important. Very important. Can you tell me the assumptions? मैंने ऊपर भी लिखवाया है कुछ. But what are the assumptions that we have to make here? Achha, one thing you should be also clear that few things which might seem obvious in quantum domain, we still have to assume in the classical domain. Okay? We still have to assume in the classical. For example, elastic collision. Yes, it will be. When we are dealing in the quantum domain, it has to be elastic collision. But when we are doing here, we have to write. Okay? What does elastic collision mean? What is the mechanical impact of that? What is the mechanical impact of that?
Conservation of energy and momentum.
Conservation of energy and
Momentum.
So, conservation as the collision, it means conservation of momentum plus conservation of energy. Kinetic energy, not energy. Energy is always conserved. First law of thermodynamics. Second, all particles are treated as point objects. That means we don't have to worry about their dimensions, their shape, their size, irrelevant. Second, third, target or the nuclei. Rutherford scattering is only for the gold foil, है ना? Target or nuclei is very massive. Very massive means very massive means very massive means
M2 is greater than
At rest.
no recoil of target plus only scattering of projectile. अरे ये नो यही तो मैंने पढ़ाया कल भी.
Yes.
When body is very massive, this we can write. And fourth, only interaction that we are considering here is Coulombic. That is only Coulombic interaction. Are taken into account. Okay. Now you should know that few things. Only means no screening effect of electron. Screening means due to the presence of multiple electron, because electrons are also there, and when you are bombarding them, so there will be not only repulsion by the nuclei, but also the attraction by the
Electrons.
If this is my nucleus, electrons are also there. So when you're bombarding any positive charge particle, this Coulombic interaction is there. So Coulombic interaction will be between the nucleus and the electron and this positive charge. So electron और इसके बीच के चार्ज को हम लोग इग्नोर कर रहे हैं. ठीक है? So only Coulombic interaction taken into account between them. ठीक है? No screening effect of electron. ठीक है? Now when we say that कि it is a Coulombic interaction, that means it is central in nature. It is a central force. And when we say central force, there are two things you should be understanding. For now, it is a 2D motion, planar motion hota hai. We will be proving in coming classes. When we start central motion, we prove that. As of now, abhi maan lo, angular momentum is conserved. इसको ऊपर ही लेते हैं ना. Now, with these assumptions, we are ready to do. Is conserved. Chalo. So, for example, let me do a few things. That if force is a central force, F is the function of Fr. That means it is a central force. Central force are those force which have been applied according to the radial or radius. ठीक है? So मुझे बताओ, what will be torque here? Torque will be R cross F. Now F and R both are in the same direction. देखो ना, R cap, it is also in the R cap.
Zero.
Zero. So if
Zero.
it is, can I say that from your previous knowledge you can say that the angular momentum is conserved? समझ आ रहा है सबको? Basic, we will discuss this thing in detail later. But basic तो समझ में आ रहा है सबको ना कि angular momentum will be conserved. Yes, no?
Yes.
First thing. Second thing, Coulombic means that the force of interaction will be equals to 1 upon 4 pi epsilon naught. I hope everyone know the formula, but फिर भी ZE into 2E upon R square. R cap. I'm not writing gold ka 2E. Why? Because we have alpha particle. Yes or no? 2E because we have alpha particle. 2E because we have alpha particle. You can also write the Z of gold, but ठीक है, उसको नहीं भी करोगे तो कम बन जाएगा. ठीक है. Next thing, the kinetic energy are conserved. Next thing we are writing that the kinetic energies are conserved. What does it mean? If kinetic energy is conserved, देखना चाहिए. Ti is equals to Tf. Ti is equals to Tf. That means P square by 2m is conserved. So can I write from here that the momentum, obviously magnitude, which I'm writing as P, will be same. Yes or no? अरे यही तो होगा. Pi का होल स्क्वायर इक्वल्स टू Pf का होल स्क्वायर बाय 2. 2m से 2m काट लोगे. दिक्कत तो देख लो. Pf का होल स्क्वायर बाय 2m इज इक्वल्स टू Pi का होल स्क्वायर बाय 2m. 2m कैंसिल आउट. Pf का होल स्क्वायर इक्वल्स टू Pi का होल स्क्वायर. दैट मींस देयर मैग्नीट्यूड आर इक्वल. Yes or no? यहां तक क्लियर है सबको? Now this is my target particle. ठीक है. Again I will be making it as a point particle only, and from here so मान लो ना ये. This is my small projectile, right? It will move from here, and this given, it is given as B. It is given as B. Now understand, there will be something which is known as distance of closest approach. There will be a point when this point will come here, right? Oh, sorry. This is the path will be something like this. The path will be something like ठीक है. So at this interval of time, it is at closest distance. At this interval of time, it is at closest distance, right? So I can simply say that this is the distance of closest approach. This is the distance of closed approach. Have you heard about this term? सुना है किसी ने? What happened at distance of closed approach?
Distance is minimum and force is maximum.
Okay.
Coulombic
So-
interactions are maximum.
Yes. So distance of closest approach, interaction is maximum. Interaction is maximum. Okay. Now we are going to write few things here. Okay. We can analyze that anything. And the interactions is maximum. That means what? Potential energy is higher or lower?
Least.
Okay. This is self-explanatory of that. Now, if I have to change, if I have to write the change of momentum, I will simply say that this is my PF. And this is my PI. Vectorly. PI vector, right? If you can just shift this vector, it will be PI. And if you mark it here, it will be something like here. That is delta P. That is delta P. Now you need to understand one thing. Understand one thing, that at a particular interval of time, right, you have applied a force. Force has been applied. Force has been applied at a particular interval of time, which is making an angle phi with the change in momentum. This is making an angle phi with the change in momentum. Now, you will be asking, sir, change in momentum is in the direction of force. How we are thinking this thing? That the change in momentum is in the direction of force, yes or no?
Yes.
So why I have written this? कोई explain कर देगा? Offline classes होती तो मैं chocolate देता. But virtual chocolate I will give you. Wrapper of that. खुद का के. बताओ. From symbol में लिखा हुआ सब कुछ. Just think for a minute and tell me. Just think for a minute and tell me. अरे भाई ऐसे काम नहीं चलेगा यार. What is delta P? Have I written dP or delta P?
Delta P.
No. So here मैंने बताया था उस दिन भी, तुम लोग ढंग से सुनते नहीं हो क्लास में. Coulombic interaction are instantaneous in nature. Yes or no? Coulombic interaction. That
Sir,
is
I was thinking in the same direction, but समझ नहीं आया express कैसे करना है.
ठीक है. It is instantaneous. So it is equals to dP by dt. But it is not equals to delta P by del T. One more thing. F is in the direction of dp, but delta p is something related to impulse. Yes or no? बचपन में पढ़ा है थोड़ा बहुत हमने. F dt. Also, delta p is what? It is integration f into dt. So at every instant, f will change according to the r. The position distance between them, it will depends upon that. So delta p will be something like that. I hope everyone it is clear. Yes or no? So delta p, it is
Yes.
instantaneous and it is about the complete journey. It is about the complete journey. Okay? This is the final momentum that we have put it. Now let us draw the diagram. Let us assume this is theta. This is theta. Now let's make triangle diagram. So geometrically, everyone should make this is my pi. This is my pf. Can you tell me where will be delta p? What is delta p? Delta p is simply pf minus pi. बताओ इस ट्रायंगल में कहाँ आएगा?
From PF to PI.
So if I make this parallelogram ही वो तो बोलते हैं इसको.
From PF to PI.
If I made something like that, okay? If I made, assume. So assume. So it will be around this thing. Simple vector calculus, not vector calculus, simple vector delta p. यही तो होता है. Pf minus pi. Yes or no? Now tell me one thing. If this is theta, what you can say about these angles? If this is theta, one thing is sure, this is theta. Parallel. अरे ये सबको समझ आ रहा है मैं क्या लिख रहा हूँ यार? ये बेसिक वेक्टर एडिशन तो आता है ना सबको? सबको आ रहा है ना? चलो. See if this angle and this angle will it be same or not? Yes. PF equals to PI. ये और ये इक्वल है. ये भी क्या है? इक्वल है. इसको हम क्या बोलते हैं? When all four sides are equal, it is known as rhombus. Yes or no? So let us consider this as alpha. So this will be also alpha. Now, if this is so, ये तो आसान हो गया हमारे लिए. That 2 alpha plus theta is equals to pi. So what is alpha? Alpha is simply pi minus theta by 2. This is my alpha. Now, using sine rule. Sine rule आता है ना सबको? How can write? We can write delta p by क्या लिखेंगे? Sin theta. Delta p by sin theta. यही तो होता है यार. पढ़ा है ना ये सब? ये एक ट्रायंगल है. ये डेल्टा पी सामने कौन सा एंगल है? थीटा. डेल्टा पी बाई साइन थीटा इज इक्वल टू क्या होगा?
PF upon sin alpha.
हाँ, P और P बताया था ना ऊपर. मॉड PF PI टू P. सो सिंपली बताओ P अपॉन साइन अल्फा.
PF upon sin alpha.
which can be simply written as delta P is equals to P upon sin. क्या लिख सकते हैं हम लोग? Sin पाई बाई 2 माइनस थीटा बाई 2 इंटू साइन थीटा। बताओ क्या आएगा ये? तो साइन पाई बाई 2 डेल्टा पी बिकम सिंपली पी साइन थीटा अपॉन cos 2 theta, sorry, cos theta by 2. So I can write simply as 2p sin theta by,
cos theta by 2.
लिख लो, जरा कर लोगे। So cos theta by, you can कट कर दो। So डेल्टा p is equals to, ये कर सकते हो, इसे कम में भी कर सकते हो एग्जामिनेशन में। This is so basic. Delta p is equals to this. Now can I write that delta p from its concept of impulse is equals to f projected in that f cos theta, no, sorry, f cos phi into dt, or I can write it as f cos phi, because it should be integrated with d phi. I'm writing is a dt by d phi by d phi. Yes, no, everyone? जल्दी जल्दी बोलना होगा।
Yes.
As we know that angular momentum is conserved. As we know that angular momentum is conserved, can I write that Li is equals to Lf? Now what is Li? एंगुलर मोमेंटम का बेसिक सबको पता है। अगर इसकी मास m है और ये v से जा रहा है, तो कहां से देख रहे हैं? इस पॉइंट से हम लोग देख रहे हैं एंगुलर मोमेंटम, राइट? वी आर सिटिंग हियर ना, टारगेट पे बैठ के सब कुछ देख रहे हैं। तो व्हाट विल बी एंगुलर मोमेंटम? कैन राइट इट एट, क्या लिखते हैं हम लोग उसको? एम वी बी, यस और नो? अरे यही तो लिखते हैं, पता नहीं था तुम लोग को यार एम वी आर वाला कॉन्सेप्ट।
Yes sir. Yes sir.
तो इट इज एम वी बी इज इक्वल्स टू, अब देखो यहां पर जब पहुंच गए, यहां पर आर लिखने के टर्म से फायदा नहीं है, बट वी नो दैट इट इज रोटेटिंग विथ फाई, it is rotating with phi. So I will use the term at the minimum distance, it is equals to I omega. And what is I? I is what? mr square. अरे least distance पे कितना है वो? mr square है omega. And what is omega? Omega is nothing but d phi by dt. d phi by dt. From here can you cut m and m? And from here, you can simply find out dt. We'll find the value of omega. That is d phi by dt. और सिंपली छोड़ो ना, हमें क्या निकालना है? dt by d phi. बताओ कितना आएगा? r square by vb.
R square upon VB.
Now put it in equation number 1. 1, 2 जो बोलना है बोलो. I should be writing equations. Put it. Put this value in equation number 1. So your delta p will simply becomes integration f cos phi. इसको लिखिए दो ना, पूरा लिख देते हैं। What is f? What is f? It is 1 upon 4 pi epsilon naught. It is 1 upon 4 pi epsilon naught ze into 2e by r square into cos phi into r square by vb into d phi. Now anyone tell me what will be the integration of d phi? d phi कहां से कहां हो सकता है? तो जहां से जहां मोमेंटम हो सकता है, चेंज इन मोमेंटम। यार f is proportional to dp, so you have to check that कि dp कहां से कहां तक वेरी कर सकता है. So if this is dp, it can vary from this alpha to this alpha, right? You can write from 0 to 2 alpha, or you can simply write it from minus alpha to alpha. पहले सब लोग यहां तक आओ, आया नहीं आया, फिर we will move ahead. Have you got this? यहां तक सबका ओके है? जल्दी बताओ यार, तुम्हें
यस सर।
हाथ रखना होता है यार बाकी लोगों को.
यस सर।
और कुछ करेगा? नहीं, है ना? तो लेट अस डू दैट. दिस डीपी हमने क्या निकाला था अभी? 2mv sin थीटा बाई 2. यहाँ क्या बाहर आ जाएगा? देखो ऊपर आ जाएगा 2z स्क्वायर, ध्यान से करना बिल्कुल भी, अपॉन 4 पाई एप्सिलॉन नॉट वीबी, इंटीग्रेशन फ्रॉम माइनस अल्फा टू अल्फा cos phi d phi. इंटीग्रेट करो. cos का क्या आएगा? sin phi. अरे करो यार, क्या कटेगा इसमें से? डू इट. 2 and 2 will be cancel out. What else? कुछ कैंसिल आउट होगा क्या?
नहीं सर।
नहीं होगा ना?
हम्म।
चलो तो फिर उसको रहने दो, आगे बढ़ते हैं. mv sin थीटा बाई 2 ze स्क्वायर 4 पाई एप्सिलॉन नॉट वीबी. ठीक है. cos phi का क्या होगा इंटीग्रेशन? cos phi का क्या आता है? sin.
यस सर।
इट विल बिकम sin 2 अल्फा. देखना ये है ना, sin 2 अल्फा. ये सुनो, which is equals to ze square 4 pi epsilon naught vb. sin 2 अल्फा क्या होगा देखना, अल्फा की वैल्यू कितनी आई है?
सर 2 sin अल्फा आएगा ना?
हाँ
sin 2 अल्फा कैसे आ रहा है?
सॉरी, हाँ 2 sin अल्फा, 2 sin अल्फा. और अल्फा की वैल्यू कितनी है? पाई बाई 2 माइनस थीटा बाई 2, मतलब 2 cos थीटा बाई 2, 2 cos थीटा बाई 2. देखो, from each calculation just confirm me one thing, that whether are you getting this thing. b की वैल्यू निकालना है हमें यहाँ से. तो b इधर चला जाएगा, नीचे ऊपर क्या बचेगा? ऊपर तो बचेगा यही ze स्क्वायर कुछ गड़बड़ तो नहीं हो रहा? एक बार देखना, शायद 2 का फैक्टर कम आ रहा है मेरे पास. हमने हर जगह सही से कैलकुलेट किया ना, 2v mv sin थीटा बाई 2.
सर न्यूमरेटर में 2 और डिनोमिनेटर में 2 कट जाएगा 4 से।
न्यूमरेटर में 2,
न्यूमरेटर में 2 cos थीटा बाई 2 वाला 2 और 4 कट जाएगा।
ओके.
1/2 का फैक्टर तो सर आएगा ही b इक्वल्स 2 में, क्योंकि ऊपर 2 है नीचे 4 पाई है.
So if it is coming out to be 2 cos theta आएगा यार तू, ठीक है, रहने दो 2z स्क्वायर cos theta by 2, 2z square cos theta by 2, 4 epsilon e naught, 4 epsilon e naught, ठीक है, इज इक्वल्स टू ऐसा कर लो, ये m और v स्क्वायर आएगा ना, तो ये mv स्क्वायर आ जाएगा ना। जस्ट टेक वन थिंग, mv स्क्वायर, इस 2 को नीचे ले लेते हैं हम लोग, इस 2 को नीचे ले सकते हैं ना हम लोग, एंड देन साइन थीटा बाई 2, अब आ जाएगा, सही है। So from here I can simply write that b is equals to z e square 4 pi epsilon naught into E of alpha, energy of the alpha particle, kinetic energy, into cot theta. What does it mean? What does it mean?
Impact parameter is inversely proportional to energy.
Also for theta also, cot theta is a decreasing graph, yes or no? Cot graph देखा है सबने, कैसा होता है, ऐसा कुछ, it's a decreasing graph other than the tan, increasing graph है ना। So b increases, theta increases, ठीक है, and b is also inversely proportional to, here more energetic it will be, impact parameter will be less. Can chalo, so considering b is equals to c by 2e alpha cot theta by 2, इस पूरे को हमने क्या मान लिया है, c by 2, पूरे क्या मान लिया हमने, c by 2. So if this is so, what will be sigma theta? Sigma theta कैसे डिफाइन किया हमने, माइनस b by sin theta dv by d theta. जल्दी करो, डिफरेंशिएट क्या आता है देखो, तो यह जाएगा c by 2e alpha cot theta by 2 अपॉन sin theta, है ना, और इधर क्या जाएगा डिफरेंशिएशन करके, ce by 2e alpha तो वैसे ही रहेगा, cot theta का क्या आएगा डिफरेंशिएशन, cosec स्क्वायर थीटा बाई 2 एंड देन थीटा बाई 2 का डिफरेंशिएशन 1/2. देख लेना कैलकुलेशन गलती ना हो जाए मेरे से, ये तुम लोग की रिस्पॉन्सिबिलिटी है। नाउ सी स्क्वायर 1 2 और ये 2 8 और ऊपर बच्चा cot थीटा बाई 2 cosec स्क्वायर थीटा बाई 2 और नीचे बचा साइन थीटा, तो साइन थीटा कर देते हैं हम लोग 2 sin थीटा बाई 2 cos थीटा बाई 2. बताओ क्या आ रहा है, व्हाट इज सिग्मा थीटा?
सर ये कहाँ से आया, सिग्मा थीटा इक्वल्स टू माइनस बी साइन थीटा डीवी बाई डी थीटा?
हाँ ये अभी तो डिफाइन
हाँ, ये
इम्पैक्ट पैरामीटर है, ठीक है
सर, ठीक है सर।
डिफरेंशियल प्रोसेसिंग है दैट वी आर, तो सिग्मा थीटा कितना जाएगा ऊपर से, सी स्क्वायर नीचे 8 है 16, तो सी स्क्वायर ई अल्फा भी है यहाँ पर, सी स्क्वायर बाई 16 ई अल्फा स्क्वायर, सी स्क्वायर और 16 डजंट मैटर, मैटर इज कॉसेक वाला टर्म, कॉसेक 4 थीटा बाई 2, प्लीज रिमेंबर दिस वेरी इंपॉर्टेंट। कैसे आएगा कॉसेक 4, अरे कॉट थीटा क्या होता है, कॉस बाई साइन, सो कॉस कॉस खत्म, साइन ऊपर जाएगा तो क्या आ जाएगा cosec? नहीं, I want you guys to find the total cross section area. ये तो differential है. Find out the total cross section area. Total cross section area. If I have to make the graph, स्टैंडर्ड ग्राफ है, ठीक है, ऐसा नहीं है कि इक्वेशन देख के बना सकते हो तुम लोग, ये याद करना होगा तुम्हें, ठीक है. दिस ग्राफ इज समथिंग लाइक दिस. प्लीज लर्न दिस ग्राफ. इट इज फ्रॉम योर एनसीईआरटी, क्लास 12 एनसीईआरटी में दिया हुआ ये ग्राफ. इज हाइपरबोलिक एंड इट इज मैक्स एट एक्सपेरिमेंटल वैल्यू है. थीटा इज इक्वल टू 6 डिग्री, पाई बाय 3. This you can make, and from here you can also write that sigma theta, the probability of interaction will increase when energy provided is less. Okay, and third also sigma theta will increase because z ऊपर आया था, when z will increase, higher order. That's why we have taken a higher order element, just like gold. Gold की z कितनी होती है?
79.
79.
नहीं.
तो हायर ये सुनो, हायर बहुत सारा फैक्टर होता है. इट शुड बी मेलिएबल बोलते हैं, डक्टाइल बोलते हैं उसको, मेलिएबल बोलते हैं, थिन शीट में निकलना चाहिए, बहुत सारा पैरामीटर होता है. सो ऑल दोस सुटेड इज सुटेड फॉर दैट. ठीक है. नाउ नेक्स्ट थिंग वी हैव टू कैलकुलेट हियर इज द टोटल क्रॉस सेक्शन. Total cross section is what? Sigma. You will integrate sigma theta, sin theta, 2 pi sin theta d theta. No need to do that. When you do that, here sigma will come out to be infinity. Sigma will come out to be infinity, right? Why? Because of two reasons.
Because we are assuming infinitely big
First
sigma.
is Coulombic interaction. Coulombic interaction are distance dependent. And second thing, due to not considering screening effect. No, एक चीज समझना. See, you have to understand this thing first. When we are studying the mechanics, we are only interested in how this mechanical interaction is working, right? How this screening effect, what is screening effect, and all those things, we don't need to go in such detail. सबको समझ में आ रहा है क्या बोल रहा हूँ? Yes or no?
Yes, sir.
We are not interested in the phenomena. We are just interested in the dynamics and kinematics of that thing. That is our only concern. ठीक है? Otherwise, our syllabus will go on increasing. ठीक है? Now, the questions of these things we will be doing in the launch session, है ना? इसके कुछ questions है. See, mostly 90% chances are they will ask derivation. 8% less chances are they will ask numerical, in which you just have to put the values, right? 4 out of 4 variables, they will give 3 variables and you have to find the fourth one. 2% chances are they will give a new question. That is also I have mentioned in your launch 3. ठीक है, नोट्स 3 में I have already mentioned all those questions that we will be solving there. ठीक है, now next topic. Based on this, one more topic which is not mentioned in the syllabus, but UPSC has often asked, is the hard sphere scattering. Now, what does this hard symbolizes? If I ask you, what does this hard symbolizes? What is hard or soft? ये समझ लोगे तो फिर कुछ बचेगा ही नहीं. What is hard versus soft? Last topic है.
डिफॉर्मेशन नहीं हो रहा है.
Deformation नहीं हो रहा. Very good, very good. Hard means that it has negligible deformation. Even it is happening, we can ignore that. And soft simply means which is deformable. So when it is deformable, can I say that when it is deformable, हमने पढ़ा था inelastic वाले में भी. When it is deformable, can I say that the energy got converted into
पोटेंशियल एनर्जी और हीट.
deformation energy? Let's
हाँ.
call it as deformation energy.
पोटेंशियल एनर्जी ऑफ डिफॉर्मेशन.
Or potential energy of deformation. ठीक है, that is deformation energy, as you said, is a type of potential energy. There can be various types of potential energy. One kind is deformation energy. But one thing is sure, when we are dealing with this soft thing, we can say that if all of them things are there, simply say that kinetic energy is not conserved.
Not conserved.
Kinetic energy is not conserved. Okay, if it is negligible diffusion, we can assume it to be an elastic collision. That is, kinetic energy is conserved. When you write like this na in the examination, ये मतलब कि soft versus hard क्या होता है, ये मैंने पढ़ाया है तुम्हें. But when you are doing the hard sphere, you will be considering hard sphere that is not deformable, means the kinetic energy will conserve and the collision will be elastic. Now assumption. Mass of target is again much greater than mass of projectile. So what does it mean? What does it mean? Only scattering, comma, no recoil. Yes or no? Only scattering, comma, no recoil. Clear hai? Everyone? So we have to deal with the geometry now. ठीक है?
Sir, isn't it hard sphere scattering is general case of classical scattering, and Rutherford scattering is a special case of that?
See, both of them are almost same. ठीक है? अलग नहीं कुछ भी. So you can see that, but here we are
but
taking dimension into
in
consideration.
context of in the context of Rutherford scattering, we are actually considering only atoms and molecules and alpha particles, etc. But
See.
general hard sphere scattering is applicable throughout the classical domain.
See, hard sphere scattering is something that we will do geometrically, right? When we are doing
हाँ
मतलब Rutherford scattering, we are more interested in Coulombic interaction वाला part, ठीक है? Here we are
yes
only focused on geometry part. This is the difference. Again, here we have taken the size into consideration. There we have taken it to be a particle. So there are difference between them. Okay. Although the concept will be same, but they are slightly different. ठीक है? चलो, ये सबको दिख रहा है? Now from this diagram, it is very, very clear that both the masses initially was at B. The radius of this is, let's say, R1. The radius of this is R2. ठीक है? Mass is, again, I already told you कि इसकी mass बहुत कम है, उसकी mass ज़्यादा है. So can you find out the B? Again, it will get deformated here. सब कुछ वही चलेगा. I'm just interested in geometry. If you see this geometry, can I say that here it is B in this triangle? This is alpha. This deflection is theta. And this side is nothing but R1 plus R2.
R1 plus R2.
So I can simply write that B is equals to, let's say R1 plus R2 is equals to R. B is equals to क्या जाएगा simply? R sin alpha. R sin alpha. Right? And what is alpha? We have already seen in the last class, last topic, that if the momentum was like that, यही तो चीज यहाँ भी कर रहे हैं हम लोग. It is your PF. It is your PI. It is your change. It is your alpha. It is your alpha. It is your theta. वही तो अल्फा है यहाँ पर. देखो. Yes or no? So here again alpha was what? Pi minus theta by 2. So if you put pi minus theta by 2, what will happen here? R cos theta by 2. Everyone getting it? This is easier one. Now what will be sigma theta? Sigma theta we have defined it as minus b by sin theta. db by d theta. जल्दी करके बताओ कितना आया? So what is b minus r cos theta by 2 upon sin theta? What is db by d theta? It will be minus r sin theta by 2 into half. यही तो आएगा. Yes or no? तो प्लस प्लस कर लो.
Yes.
है क्या? देखो क्या आएगा. It is coming out to be r square by 2. ऊपर आ रहा है sin theta by 2 cos theta by 2. You will see a very, very beautiful thing.
Sir.
ये तो इससे कट जाएगा 2 times में.
हाँ.
It is coming out to be sigma r square by 4 और again r1 plus r2 square by 4. दिख रहा है जो मैंने बताया था स्टार्टिंग में, that it is coming out to be a constant geometrical parameter. अच्छा यहाँ पे याद रखना, वी हैव टेकन द कॉन्टैक्ट फोर्सेस, है ना? ये अलोंग वे कहाँ है? It is along LOI, along the line of interaction. ठीक है? Now everyone, find out sigma. Sigma is what? Defined as, सब लोग बोलो, sigma theta 2 pi sin
2
theta.
pi sin theta d theta.
What will be happening here? 0 to pi r square by 4 2 pi sin theta d theta. It is coming out to be, देख लो सब कारण यार, pi r square, that is pi r1 plus r2 का होल स्क्वायर. यही तो आएगा और क्या ही आएगा. देखो अगर प्रोजेक्शन भी देखोगे तो यही गोल 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 हर जगह है. So even if you find the detector, this is the total cross section area that it can have, that is pi r1 plus r2 का होल स्क्वायर.
सर अभी आपने आखिरी में क्या बताया, पाई r1 प्लस r2 का होल स्क्वायर कैसे विजुलाइज करवाया?
मैंने बोला कि व्हाट इज क्रॉस सेक्शन एरिया. हम वेक्टर लगा रहे थे ना और देख रहे थे यहाँ पे तो कोलिजन का क्या है, ओनली कॉन्टैक्ट बेस्ड कोलिजन है. ये सुनो, तो इंटरेक्शन तो बस यही होगा जब तक ये साथ में रहेगा.
ठीक है सर.
दिस इज व्हाट द सर्कल.
हाँ सर ठीक है.
ठीक है, ये बोथ हैव सेम रेडियस, that is r1 equals to r2 equals to r, then sigma can be equals to क्या आ जाएगा, 4 pi r square. It will appear as a sphere of that. ठीक है, again doesn't matter it is identical or not, just only thing that matters here is they should be having the same radius. ठीक है, और पढ़ोगे?
सर अभी आपने मेरे को 2D में विजुलाइज कराया था पाई r1 प्लस r2 का होल स्क्वायर.
एरिया ना 2D ओनली.
एरिया, और लेकिन सर जब ये r1 और r2 कर रहे हैं, r के बराबर किया, तो ये सर कुछ ऐसा स्फीयर का दिख रहा है.
स्फीयर दिख रहा है बट स्फीयर है थोड़ी,
है नहीं ना, मतलब वो तो बस निकला है ना कुछ.
है बस कि r और r इक्वल, तो r प्लस r 2r हो गया. 2r का
अच्छा, बस मतलब कुछ उसका स्फीयर से कुछ लेना देना नहीं है.
इट इज 2 into pi r square, 2 into 2 pi r square. ठीक है,
हाँ ठीक है.
समथिंग लाइक दैट. मतलब अगर और 15 मिनट पढ़ोगे तो वी कैन स्टार्ट विद द वेरिएबल मास सिस्टम. तो ये टॉपिक हो गया है.
नहीं सर, बस हो गया
ना टाइम. चलो वी आर एट आवर पेस. देखो अभी ये लेक्चर कितना है, 8 है ना, तो ऑलमोस्ट कितने लेक्चर्स होने वाले हैं? अरे यार कितने लेक्चर शेड्यूल तुम्हारे अभी देखा नहीं तुम लोगों ने?
और 2 होगा सर.
सर 10 ही है, मतलब कल परसों तक. हाँ सर 10 ही है.
ठीक है. सो व्हाट वी विल बी डूइंग, मैं बता रहा हूँ तुम लोग को. सी वी हैव अ स्मॉल टॉपिक ऑफ हाफ एन आवर, दैट इज द वेरिएबल मास सिस्टम. ठीक है, वही जो रॉकेट प्रोपोर्शनल वाला है. आफ्टर दैट वी विल स्टार्ट दिस एप्लीकेशन टू रोटेटिंग फ्रेम, सेंट्रीपिटल एंड कोर्डलेस एक्सेलरेशन. ठीक है, एंड देन वी विल स्टार्ट विद मोशन अंडर a central force if time persists. ठीक है, कंजर्वेशन ऑफ मोमेंट, एंगुलर मोमेंटम, केपलर्स लॉ एंड फील्ड. ये 2 क्लास में जितना हो पाएगा उतना करने की कोशिश हम करेंगे. ठीक है, मोस्टली मानो तुम यहाँ तक तो हो जाएगा, सेंट्रल तक हो जाएगा. सेंट्रल एंड केपलर्स लॉ, फील्ड पोटेंशियल तो अलग है. केपलर्स लॉ, सेंट्रल फोर्स and this all rotation in 2 classes it can be done, and trust me these are all your basics of that. ठीक है, तो प्लीज उसको ढंग से करना. उसके बाद देखो these this take only 2 classes, एक में सॉलिड एक में लिक्विड, कुछ खास नहीं होता. ठीक है, so these are very very small topics, either it is given as a different schedule but ये बहुत छोटे छोटे टॉपिक्स है. एंड दीज आर थिंग्स जो हर जगह काम आएंगे, इवन इन अदर मॉड्यूल ऑल्सो। ठीक है, चलो फटाफट रिवाइज करो जो भी हमने किया आज का। गिविंग यू 2 मिनट्स, रिवाइज एवरीवन। So mainly we have started with the scattering, then we have understood the concept of differential cross section. ठीक है, then we have seen the impact parameter, right? Then conversion. Based on this conversion from lab to center mass frame, I have very good question that we will be doing in the numerical session. Rutherford scattering, then we have started. चलो 2 मिनट दे रहा हूँ, जल्दी देखो, डाउट है तो। Now please, this time came, अभी तक हमने बहुत सारी चीजें पढ़ ली है, बहुत सारा डेरिवेशन पढ़ लिया है, तो प्लीज ट्राई टू रिवाइज देम अगेन एंड अगेन। इट शुड बी ऑन योर फिंगर टिप्स, इट शुड बी। अगर मैं तुमसे 10 दिन बाद पूछ लूं कि व्हाट इज द इंपैक्ट पैरामीटर फॉर्मूला, तो तुमको बोलने आ जाएगी जेड स्क्वायर 4f0 e अल्फा इनटू cos थीटा बाय 2, इतना होना चाहिए फास्ट, राइट? इट शुड बी दैट मच इन योर फिंगर टिप्स। चलो ठीक है, आई थिंक everything is clear now, so that's all for today. We will meet tomorrow. हाँ
सर ये नोट्स अभी दे दीजिएगा, क्योंकि बीच में ना नोट्स बना नहीं पाया, छूट गया।
अभी कर दे रहा हूँ, 5 मिनट में, ठीक है, आपको देख लिया। ओके,
थैंक यू सर।
चलो, that's all for today. Thank you, good night, bye bye.
थैंक यू सर।